Okay, evening stream. Begin. Stream number 21. Gosh, I'm always getting that transcoder. There must be like a ton of transcoders now. Or just Twitch likes me or something. All right, this is where I left off this morning. I've been messing around with this bitstream trait that I'm using to represent the input to my program. And really quickly, my program is designed to pull apart the bytes of some binary file or stream, assign meaning to each one of those bytes. I want to reword that. Each one what, right? Pull apart all the bytes of some binary file stream and assign meaning to every piece of it. Yeah, that's what I want to say that. Based on a description of the format. Based on a description of the format of the... how about... What would you say data format? There we go. Yeah, so the DataDisintegrator. Shouldn't that say pulls apart? Pulls apart all the bytes of some pulls apart all the bytes of a binary file stream and assigns meaning to every piece of it based on a description of the data format written in a domain-specific language. Exactly, that's what it does. This is the domain-specific language. So, for example, if we have this GIF file, these bytes are going to be interpreted as this structure. So, let's try that again with the less at the end. So, starting with header. Header has a string, signature, 24 bits long. Then it has a string version, 24 bits long. So we take these first 3 bytes, interpret it as a string, and there you go, GIF. Next 3 bytes, 89A as a string. And after the header is the logical screen. Logical screen has a logical screen descriptor, and that has this logical width, screen width and height. And each of those LEUI 16s is just 2 bytes least and most significant, and we shift the most significant up and add the least significant. So that's this 2C and that 1, that's 44 and 1. Shift left the MSB 1, that's 256. 256 plus 44 is 300. Hopefully that explains what my tool does, and you might be able to extrapolate from that we're making something like Wireshark. So we receive a whole bunch of bytes as input, and then we parse it depending on how what format I say the data is. It would generate. We would have some user interface around it eventually that would show really interesting things about it. Like at the top level, what is it? And if you click on any element, you get more detail, and you can click into the detail to see individual bytes, all that good stuff. So, like this table here suggests, I first wrote it in C and C++. That was about 5 years ago. Now I'm porting it to Rust. And the tool is basically 3 pieces. And to break them up properly with nice interfaces between and have a little test for them, I have abstraction layers between and shell programs to test them. So the Lexer is the first step. And that's where we take our program. I didn't mean to type that. Let's go back up. Yeah, there's our program, right? And then here's what that first stage Lexer does is it turns our program into a sequence of tokens. So a token is like either an identifier or a number or a piece of punctuation, but all the white space is stripped away. All the new lines are stripped away. And so it sort of makes a uniform form of what we wrote. It would be the same no matter how much we indent, etc., etc. Why does it think I changed it? Because I did accidentally change it. All right. Okay, let's close that. Actually, let's just go back here. So that's what the Lexer does. We have a thin shell around it called Lex, and I didn't actually have this as an independent library in the C days 5 years ago, but now I do. And the Lexer, we can test it with Lex, which is the program I just ran. It outputs the token stream, and we have a type called token, which is abstracted away from the implementation of the Lexer and the parser, so it's an independent library. So it looks like this. So absolutely no dependencies. It's just a plain data type, right? That's all it is. Then we use a string of those and we feed it into the parser. So following the grammar of the language, the token stream is turned into an abstract syntax tree. So the abstract syntax tree kind of looks like this. We go down to where the GIF is defined. You see it's pretty much mirroring our input program, but it's a compact data structure in memory, and by walking through that structure, we can recreate what the program is. It's in a form that's much more suitable for the computer to use. So here's the top level thing, format. So a GIF is a format, right? And it has statements in it. So a format has a name and it has statements in it. Statement can be a part statement. So like that's like would be like header and trailer would be parts. Could be an ignore, which is to parse the bits but drop them. Conditional will be like an if or an else. We have loops. We have other things. And we have like return statements and stuff like that, because like sometimes we'll return. So that's all well and good. What do we use this abstract syntax tree for? And again, I have that. We were just looking at an AST library, which does not depend at all on the implementation of the parser. So it's completely independent. It goes into a third piece, which is called the ingestion library. I used to call it decomposition, now it's ingestion. So we use that AST to break down binary data into elements. So that the C version of that is what I was running a little bit ago. That's taking, I guess I closed it. This input character stream, right? And walking through it in order, while we're doing an in-order traversal of the abstract syntax tree, represented by, I think I know why it closed, represented by the, oh, where is it? I'm slow in the uptake, aren't I? So if you imagine this is the abstract syntax tree, and this is the data, we would walk through it in order. So GIF starts with header, header has this signature. So we, using that and these bytes, by the fact that there's a 24, we bound it so that we're only looking at the first 3 bytes, interpret that as a string, and that's exactly what the tool does. And then we just repeat that process until we get all the way through to the end of the tree and the file, and hopefully those coincide. So the trailer being the last part of the file should be the last element of the output, and it should take the last byte of the file, which it does if it's well formed, right? Go all the way down, and 10E115, that's indeed that last byte, which is a 3B or a 59, right? So cool. So I'm in the middle of porting that from C++ to Rust. And we're going to have a thin shell to like test this. The output is going, I should actually write this. The output is going to be a composite data structure. And we have a data type for that. Here it is. So the entire file is condensed and interpreted to be a composite structure, meaning we can have the outer is a data component, and then the children are also data components, and it can nest however many levels we need. It remembers the format, so at the top level it'll be GIF. It has a value if we had if we associated a value with it with the return statement. It remembers the format, or I already said that. Yeah, it tracks the subset of the input that corresponded to that value, and then it records all of its components. I've only gone 10 minutes in. I'm already losing my voice. Streamer fail. Okay, so the type for bitstream is getting a little complicated because there's a lifetime involved. Because the way like one implementation of this bitstream is going to be buffered bitstream, where we're going to hold on to a reference to where the data is, so we don't have to copy it. So if the implementation has a lifetime, and the interface says we need to be able to generate subset objects, then I think, so we haven't proven this yet because we haven't gotten this to compile, but I think if we say that subset returns a box trait object which has the same lifetime as the trait itself, which would be which carries over in this implementation, then I think it will work. So subset generating a box trait object is going to make a new self with a subset slice. And it's this file Rust Analyzer doesn't have any problem with, so I think we're good. My voice has that tickle, which means I've been like stressing my voice out too much. And I didn't really talk that much at work today either. Okay, but I'm going to be chasing down these errors. I was doing this all this morning. Okay, yeah, so in order to use a lifetime, you need to declare it. So it's if it's a function or if it's an impl, you have to actually, if it's a function, we declare it in front of the name, I think. So we'd have to put it here. Yeah, and that the data component also is bounded by the same lifetime. I didn't mean to open that. I just meant to hit save. Okay, we're getting there. Lifetime may not outlive enough. Cast requires that bitstream must outlive static. Lifetime? So why does the cast require bitstream must outlive static? That's what I don't understand. Is it that this should say plus? No, that's for traits, right? This is a concrete type. The concrete type has a lifetime in it. Bits is a reference to a bitstream with a certain lifetime. Do I need to say like bitstream there? Nope. Definitely don't. Let's get a better diagnostic by like clearing all this and doing cargo clippy. Error messages Rust compiler gives us, or clippy gives us, are actually kind of nice. Okay, argument requires that 1 must outlive 2 if part has a type data component of lifetime 2. Okay, are we looking at the same thing? No, we're not. I want to look at the error that's on line 20 of tests.rs. Oh, because we didn't tell it to do the tests. Tests. There we go. Okay. Here we go. Lifetime bitstream is defined there. This requires that bitstream must outlive static. Why does it say a cast? Cast requires that. Maybe it has to do with what we're returning. Let's look at data component. Actually, let's look at data component new specifically. Oh, I think it has to do with this, which we have another error for, right? Yeah, lifetime may not live long enough. So we need to actually say here that we actually need to use that lifetime bit stream and make that the same bit stream and put that in front there. And braces. Okay, now that's okay with it. Okay. Back to here. No, back to tests. Did tests actually build now? No, it's still broken. Oh, I was hoping. So clear. Okay. Lifetime bitstream defined here requires that bitstream must outlive static. Let's call the lifetime of this reference 1. Returning this value requires that 1 must outlive static. The requirement occurs because of the type data component, which makes the generic invariant. Okay. It's that type that we need to attach the wait, but I thought we said it. Where's this anonymous lifetime then? Bits. Oh. Yeah, because it goes in there. Can't we just say that that's bitstream? Okay, that didn't actually solve it, but maybe we get a different diagnostic here. Okay, this is all we get now. Lifetime bitstream defined there. Cast requires that it must outlive static. Outlive static. I think maybe it might have something to do with how I've defined how I'm using box. Do I have to like say plus bitstream out here or something? No, that's not even valid syntax. See, I thought by putting that there, it wouldn't no longer be a static lifetime. Oh, here we go. That's a problem. Yeah. Yeah, it's because yeah, okay. So then right, this should be bitstream. We need to put that everywhere actually, right? All of these methods that take a reference, we need to clearly say it's no longer than that. And then I got to put that around. Why did I put it on input? Oh, that's the word I'm using. Okay. Input. What's that problem with that? Method not compatible. Why not? Hold on. Hold on. Where's my bitstream? Oh, it's right next to it. Yeah, I forgot to put it there. And there. Okay, nothing wrong with the trait now. And nothing wrong with the implementation. Great. I forgot that we need to put length in there. So that we should pre-compute that and add len, right? Actually, no. What it is we need to read up to, if we take offset and we add length to it, that'll give us the bit after the last one we need. So then we would divide that by 8 and then subtract. No, we don't subtract that, right? It's just a position. So it would be offset plus length divided by 8. There. Cool. I think that's right. So this is here just in case that we make a subset of the bit stream that starts mid byte, then we would ignore the previous bits. I'm just thinking now, in the end, if data just has a bit stream reference, where is it? Right here. You can't ask the bit stream like where it is relative to the original, the outermost, right? I think we might want to record that as like maybe offset. But I can add that later. It doesn't have to be added now. I want to get all the errors handled. I got a lot of errors here. Okay, so it all has to do with these lifetimes, right? I'm gonna have to annotate all the damn lifetimes, aren't I? Right now I'm not doing that, and it's a problem. What if I could just what if I just simplify it and say that there's just one lifetime bit stream, and then everything lives no longer than that? You'd use a separate lifetime if you want to allow this to be a smaller lifetime, but I don't think I need that. So I just put that there, and when you do that, you have to declare it up front. Okay. Okay, and for this to work, it's probably going to want us to say this stuff, right? See how minimum I can do to get... Okay, what's wrong with that? It's declared... Oh, it's not. No, because this is a free function. Yeah. I guess we do that, right? And then I have to do that. I have to put the same reference on all of them. Maybe? No? Hold on. Set that, and then what does this do? Cannot borrow as mutable because it's borrowed immutably. Immutable borrow occurs on line 70. Wait. Oh, it's too long. Um, we only want that. Actually, that means I don't want to use that lifetime there at all, right? Hold on. What is the exact error we get there? There's a lifetime declared at the top. And so the argument on line 70 requires that that it be borrowed for that long. Okay, so this is doing an extra long borrow then, right? Because of that. Okay, so what if I have like a shorter lifetime that's no longer than bitstream? So, do I have to make it generic? Like, I don't know, call, where bitstream is longer than the call. So now I don't quite know if I'm doing it correctly. Method not compatible. Doesn't necessarily outlive the lifetime of input. Oh, that's call. Okay. Okay, cool. Now I compiled that, right? What's this? Unused. We don't use the context. Is that true? I guess so. Yeah, because it's all within the context of that. I wonder if that means I can make the elementals like methods on data component itself. Okay, I'm gonna ignore the warnings for now. I'm gonna run into the same problem with this lifetime being so long, right? Actually, no, it doesn't return anything, so we should be good. This just feels wrong though. Let's see if I can get away with not specifying some of these lifetimes. Okay. It was okay with that. What if I get rid of that? Then that's not okay because explicit lifetime required in the type of data. Lifetime bitstream is required. Yes. Okay. But we didn't need, I guess because we didn't use context. Didn't mean to open that. Okay. We're getting these errors dealt with. One by one. Oh, this feels totally wrong to me. Borrowed data escapes outside of closure. Oh, is it is it because of that again? I think so. So let me attempt to fix. So I guess that also needs a call. Where bit stream call. Okay, we'll fix buffered bitstream. Okay, and then back to, okay, so that fixed that problem. Moving on, down to 14 errors. We don't have composite in, oh no, we do. It's probably this, right? Okay, so then this has to be generic over that, right? Actually, it's, yeah. So that goes there, I guess. Okay, we made it through that one. 16 errors. And more lifetimes. Yes. So, generic over some lifetime. Okay, getting there. Oh, wait. There's a problem here. Borrow part occurs here. It does not live long enough. Borrowed values dropped while still borrowed on 250. Cannot move out of part because it is borrowed. Borrow. Okay, is it because the borrow lasts too long? Because ingest part. Borrowing the part for too long. So then what, I have to do a call again? Where bitstream lives longer than the call. Yeah, okay. So far, so good. Now we get down to here again. Suppose the lifetime required and the type of context. Lifetime call is required. Yeah. That's fine. Okay. 13 errors. Cannot borrow context as mutable because it's also borrowed as immutable. Immutable borrow cars a 269. Oh yeah, look at that. That is a problem. Why didn't I have that problem before? Evaluate expression is mutable on self. Why do we say it would mutate the context? Composite. It shouldn't, right? Yeah, what if I just remove that reference there? Does that fix it? Yes, it does. Okay. Context and data, right? Cannot borrow context immutable because it's also borrowed as immutable. Same problem, right? We don't need a mutable context. You know, I forgot to turn my light on. There we go, nice and bright. Get that bright light going. The light of truth. It's gonna reveal all 9 of the errors I have here. I don't like the fact that I can't make that mutable. It makes me think that the way I did this match is bad. But I suppose it makes sense because we are borrowing the bitstream mutably. Actually, shouldn't the borrow expire? Okay, like, so for example, if I made that mutable, like, what's the deal with that? Why is that an error down there? Immutable borrow occurs way up here at 269 in the match. Yeah, but don't we toss it? Oh, it's saying something about that. Oh, yeah, okay. Hmm. It's because of this subset, right? It's this again. This should be a call. I don't like that I'm having to add these calls. I never had to do that before. Okay, and then back to buffered bitstream to change that subset. Call where input call. I suspect that I'll probably be able to get rid of the calls once I get rid of all the other errors. Okay, is this fundamentally the problem? We need to make the call longer because why? Because we're taking a slice of that. Oh, that's the problem. Okay, I see the problem. If we borrow the bitstream and the bitstream itself has a reference in it and we take a subslice, we need to make sure that we don't hold that reference longer than the original borrow. So it needs to be actually bounded by input, which it is. Wait a minute, then why is this a problem? Why this be a problem? Input lifetime may not live long enough. I know where they're defined. 18 is where input's defined. That's defined there. Okay, I kind of see that. I kind of see the thing, the problem. So we're going to undo that and say that if you call subset, you're going to be borrowing that bit stream immutably. Oh, that's going to be a problem though, because then we can't actually mutate the parent bit stream, can we? Yeah, I think I think I dug a big hole for myself here with this. So are we down to just like, what are the errors we have left? It's all in ingestion, right? No errors outside of ingestion. No, the tests also have problems. Because probably the same reason. Hey there, Geo52 Ray. Is there a way to avoid the lifetimes? Yeah, I would have to give up not copying the input. Or I just make it so that the input has to have a static lifetime. So if I made that be static, then this problem would go away. Basically clone and take the performance hit. Well, yeah, I would use a vector of bytes there. But then the problem is that means every single element of the file is going to have a heap allocation, and I didn't want to do that. I wanted to have just one original file in memory, and then the entire data structure just has pointers into it. That's what I'm trying to do. Yeah, this didn't. Well, that's the problem. Like, this has to be mutable. Yeah, in fact, why didn't it complain to me about that? Composite. It's probably trying to complain about that because actually it doesn't. We turning something immutable into a mutable thing. But it's about the static life. It's about the lifetime thing. Lifetime issues suck. Why does it have to outlive static? That's what I don't quite get. This new doesn't require that. It just requires that lifetime. And which is that. It's borrowed. Move out of borrow occurs on 22. Oh, is it this problem again where it's for that entire lifetime? Wait, it shouldn't be. Yeah, it's that. Crap. So let's see if I can do this. Only borrow it for the call where bit stream is longer than call. Yeah, so then it has the problem where it can't store it in there. May not live long enough, right? But wait, why doesn't it live long enough? Lifetime. This is only of the light of the call. Only this only lives as long as the call. Is it because of this? Yeah, I think this is just a big mess right now. We did get it down to 7, so we're almost there. We're so close. This needs to be mutable, right? Because we want to advance the opposite of bits. But actually, this doesn't even do that. That's a bug. This is actually wrong. Shouldn't that... Why am I doing that? I think I remember why I'm doing that. This is in the test, right? Yeah, okay. Right, yeah. It wasn't supposed to do it this way. They're both supposed to use it. So, hold on, let me think about this. Okay, okay, I think I'm stuck. I need to go back. I need to back it up. I think I already did. Hmm. Yeah, I think we're gonna remove all of these. Okay. It didn't take long. It doesn't take much to clean this up. I think we're gonna get rid of subset. I think that there's a problem here. We can't generate a box that lives as long as the borrow of the bitstream. It just that's a problem. Maybe okay, what I'll do is I'll solve it without a subset. So without a subset, that means the original bitstream has to be carried by every component, but the component has to remember its own offset and limit. See you, Nightshade, dude. Can you show the function again? There are lots of functions, so I'm not sure which one you meant. You're going to Vegas during TwitchCon, but not going to TwitchCon? If I happen to be in Vegas and TwitchCon is going on, I would at least hang out with people at the bars after TwitchCon. I hope you're doing that. You're hanging out with people who are also going to Vegas at the same time. Just trying to wrap your head around what's going on here. What's you mean in a more top level sense? What I'm trying to do is port from C to Rust this library that pulls apart data using a format that's written in a DSL. So it kind of looks like this. And we compile this into an abstract syntax tree, and then we walk through that with the data to generate a composite data structure, which is what that data was. Lost. I'm lost. I need... I didn't want to go to the other workspace. What happened to our... Oh, we minimized it. Here it is. We're making a tree of this that represents the data that we parsed for this format. So it's going to mirror this. It's like the top level node is going to be GIF, and then it'll have a header, a logical screen, a data, and a trailer, right? In the keyed children. So originally I was going to have every component in the data, this whole huge tree of data structures, have its own like window into the input, so to speak. But the problem is that this lifetime infects everything, and there's a like how to generate that box. I don't quite have that right. That's essentially what it is in this trait here. So I think the problem is if we want to have a box that's going to live as long as the original bitstream, we have to borrow the original bitstream for that long, and then that infects everything that everything has to live that long. So we end up having references that have to stay valid for longer than their calls, and things escape, and it's all a big mess. Gonna see if you can meet up with Prime at some point. Oh, great, cool. Hey there, they wrapped. So this idea of being able to, basically it's a clone, but it retains a lifetime. That's a problem. So fundamentally, we want each node to have an independent lifetime, which means that we can't have implementation that depends on a lifetime and have that lifetime. So because this is the actual implementation of Bitstream, right? And it actually has a reference in it. But if I start generating boxes that have the same lifetime, Rust doesn't know that once we're done generating the box that's the problem. Rust, I don't know how to tell Rust that when subset returns, we don't need this self-reference anymore, because what we got out of it was this reference, which we then put into the new one in here. I tried to tell it that with this, saying, well, this box can't live any longer than that lifetime. But it thinks that this self-reference might get baked into that box too, which is not correct. Dying bitstream static doesn't mean the reference is static. It means that the struct can be allocated with a fixed size. No, lifetimes have nothing to do with size. Size is whether or not you know how many bytes the concrete type has. Lifetimes are about how long references are valid for, not if they're sized. Okay. Thank you. I was handed some green vegetables to eat. When what? Static? I'm pretty sure that's wrong. That can be allocated with a fixed size. Pretty sure static means that it can be that it has to remain valid for the rest of the duration of the program. Okay. Anyway, I'm going to clean this up. So we're not going to be generating new bit streams. We're going to have the original bit stream. I suppose that means we're going to have RCs instead of box here. RC. This is still true. So you're saying that this has a different meaning than this. So my understanding is this means that this reference is valid for the rest of the program. I interpret this to mean that whatever implements this trait has to live for the rest of the program. So you're saying that that's not what that means? So like, if I were to make a structure that has a reference in it and it's has a lifetime of less than static, and try to use it in a context where that's needed, it would fail. So, okay, then I got it. They both mean how long an object lives. This refers to the borrow of the value of that type A. This refers to whatever is implementing this trait can't have a borrow in it that lives less than static. Okay, I must have misstated it before then when, yeah, anyway. I think this is what I want, right? Because I want to be able to mix and match data components, but I want the data components to refer back to the original bitstream object. So we'll do it by reference count. And if it has to be shared across threads, then we'll have to do something like with interior mutability or something, because I'm not going to mess with that at this level. Okay, so data component carries a lifetime because this reference carries a lifetime. Point is, you should do box dyne, bitstream plus static. But I don't want it to live for the rest of the program. I want to be able to use it in contexts where it can't live the rest of the program's duration. Like, right, like here. This buffered bitstream, well, okay, this is static lifetime, but what if it wasn't? Then what we get for data here can't escape. We don't want data, we don't want to be able to say return data if like this is let input, like if we did this, this would be a problem, right? That means we have something that lives longer than lifetime of input. It escapes. I should get a compiler error for that. That's not what it means. Yes, it doesn't do that. Look at the Rust book. That's okay. I'm not going to look at the Rust book right now. Why is it changing everything? Oh, because that's the last change I did. Okay, fine. I'll look at the Rust book. I think I must have looked this thing up like a dozen times already now. Okay, so this would be what, under trait? If you're going to tell me to look at the Rust book, you could at least tell me what chapter of the Rust book. I don't want to have to find it. If you're the one telling me to read it, please tell me which chapter. Also, I'm just going to go back to what I was doing. I don't know. I don't know where it would be. The title is static. Okay, let's just look static. The static lifetime. Okay, that didn't help. There's no plus static anywhere here. What if I search for plus static? It's not actually looking for the word for the plus. I hate search things. Shouldn't it be able to? it's not going to help me. I don't know. Search nowadays is a mess. It's I think probably because the plus means something special to it, right? Yeah, this is like too much junk here for me to go through. Yeah, forget it. But you get what I'm saying, right? I want to be able to like make a bit stream that's it's on the stack in this function, but I want to be able to I don't want it to allow it to return a data that outlives it. So this data, it's borrowing from those bits. It can't live longer than the bit stream. So it can't have a static light like the static lifetime. None of this has static lifetime. It only lives as long as the test runs, right? So I don't expect static to be anywhere there. Plus means obligatory in Google, Yahoo before that, and its derivatives. Yeah, that's why the search is problematic, right? Let's clean up. So there's no subset the way I'm thinking about doing this. Yeah, this should be much simpler. And I guess, you know, I don't really, it wants me to have is empty. Yeah, we're not baking in the bitstream in these lifetimes. Definitely not. Hey there, winter coding. Yeah, well, you know, I could always just ask ChatGPT. It would figure it out for me, right? Okay, buffered bitstream. There, all this call garbage goes away, right? Call, where are you? All the calls delete. All the call space delete. All the input call delete. Delete, I said. All the wheres delete. Okay. And that goes away. Actually, this whole function goes away. To the abyss. Okay. And then we're cleaning all this junk up. So actually, wherever I have this call junk, we're deleting it. Everywhere delete. Bitstream call. Everywhere delete. Okay, deleted the where for me. That's nice. Okay, cool. So that means we're not doing this. We're doing a couple things. It's going to be part.offset equals bitstream the offset. Part.limit. Yeah, part.limit is this. That's how many bits it can be starting from the offset, right? Okay, and then this is just going to copy the reference. So it's going to be bitstream.clone. Okay, why is that a problem? Option, oh, right, because it might not actually be it. So it should be bitstream.map. Well, as ref. Bitstream is a reference though, right? Yeah. Bitstream, oh, hold on. No, wait, why didn't that work? Oh, right, it's sum. If there's no bitstream, well, it defaults to none anyway. Yeah, okay. Okay, you found it. Okay, let's read it. Okay, rest has a few reserved light names. One of those is static. You might encounter in these situations. Okay. Both are related but subtly different. It's a common source of confusion. Not just when we're learning Rust, but when we've been using it for 3 years. Reference lifetime. Trait bound. Okay. As a trait bound, it means that the type does not contain any non-static references. The receiver can hold on to the type for as long as they want. Yeah, so I don't want that because I wanted it to be able to hold a non-static reference. So it can't, I don't want to do plus static. If I do plus static, then I can't make, this type can't exist. This type has a non-static reference inside. So the bitstream can't be static, that therefore, like, when it's used as a type, it can't be plus static because that won't work. Yeah, we don't want them to be able to hold it on for as long as they want. I understand that own value data has a static lifetime. That's true. Yes, but a reference data just generally does not, right? So when we say that, this is just another way of making it generic, right? Yeah, this won't work, right? That's a compiler error. Because that reference to I is only valid for the lifetime of the main call. This said it has to be static, so this won't compile. Doesn't live long enough, right? Yeah, they are complicated. It's been two or 3 years now. I still don't really understand it. I mean, that's what my understanding was. So I just think that I think that the way I was trying to do this wouldn't have worked, which was to have this thing. This thing can't work because this is saying that but the thing inside the box can't have any references that last longer than the borrow of self, which is, and also the original structure, which is a problem because well, this is mainly the problem because the way we got into copy that was through this reference. It can't be a shorter one because it said then our box wouldn't live long enough. So yeah, I just think that I think that if there's a way to do that, I don't know how to do it yet. It'd be very complicated for me. That's okay, Geo52 Ray. Don't be sorry. I'm mostly frustrated with myself for not really, because like I felt like I was almost there and it would have worked the way I was thinking about it, but Rust has rigid rules here and there, right? Like in my mind, I thought we should be able to borrow an object of this type just long enough to create another structure with the same reference, as long as we said that the thing we're making also has that same lifetime. But the way I did it here, it didn't like me doing that. So we're using this reference just long enough to slice that input. But I think it's just like there's no way to express that we want a slice that can live as long as input without self lasting that long. So the moment I constrain this reference to be less than the input lifetime, then it said, oh, well, then this is going to outlive this lifetime because this one's shorter. And it's like, well, we're only accessing that to get into this, which has its own lifetime, right? So maybe there's a way I could do it. I just didn't like express it well enough. So maybe we'll try again in a little bit. That I want to get this back to a compiling state right now. So yeah, so do I need? I don't really need that now to get this to compile, right? Actually, I think I do actually need it because when we calculate if we have enough bits, we're gonna have to use the limit. Okay, so let's just add it. And the original C code had the comments for this. Do I not have that open? I do. I just couldn't see it. Yeah, we have this like boundary and it's in here actually. Come, I can't click that. Okay, I can. Yeah, offset and limit. Here we go. We're just gonna copy it from the C code over to here. offset there and limit. Okay, L. Going alphabetical, right? Let's turn these into those. Okay, and then cut, word over, colon, paste. Go to the end and comma. This is a usize. The number of bits left in the innermost bounded region containing this component, counting from the first bit which makes up the data of the component. Right. This is the offset in the bit stream of the first bit which makes up the data of the component. Okay, so this is all good. And it's consistent with how I did it in C++ anyway, so I think we're good. Okay, so we need to initialize this stuff. Wait. Will we know the limit? The initial limit? Let's pretend that we do for a little bit. So actually, why don't we just we should initialize it from bitstream is what we should do. Let limit actually, some of these don't even make sense. If there's no bitstream, there's no offset or limit, right? That makes me think that I should put offset, limit, and bitstream all in the same place. Right? Shouldn't there be like a pub struct bitstream subset? Or yeah, and then we would put this stuff in it along with these two. Doesn't that make more sense? And then we remove this option. And then we make this generic on that there. Okay, and then we would have if the component was actually parsed from the input, this holds information about where the component came from. Okay, so this is like, I need to name this like origin. Let's call it origin. Where did it come from, right? So it's an optional bit stream subset. Okay. So then what I can do here is I can say let origin equal bitstream map bitstream, and then this is origin. If so, this would be a bitstream subset where we have the bitstream in here. But before I can do that, I actually have to compute the offset and limit. It's fighting me. There we go. Could you implement like index range and string? Oh, rather than having two usizes, you mean? Like actually have a range? I've had trouble using the range type. Like, so maybe I can revisit that. What if I make a to-do for that? Like, consider using, you said index range. I don't know if that's the same. For bitstream subsets. I really should have proper syntax, proper English sentences. They should all end in a dot, right? I haven't been very consistent about that. Here, dot. No. dot there and there and there, right? There we go. Okay. But yeah, let me do one thing at a time. We might go back there and use a range or an index range. I just need to understand what an index range is, and I don't actually know right now. Okay, so the let offset equal bitstream offset, right? Let limit equal bitstream dot length minus offset. And then we can get rid of these then. Cool. So if the component has an origin, then don't I want to just clone it? Oh, I guess we're forcing the caller to clone it, right? Well, we could do that. Then I would have to clone it. I think we're gonna force the caller to clone it. By stream subset? Probably. By stream. No, no hits on by stream. Nope, I didn't misspell it by stream. Oh, bitstream. Oh, bitsteam? Bitsteam. Oh, yeah, I did. Thank you. Bitsteam. I guess the R key is getting weak. Thank you. Any more bitsteams? How about any more steams? There shouldn't be anything named Steam. Nope. How about Sturm? Nope. Got lots of streams though. Okay. Okay, so just 11 errors and one warning. Isn't index range just magic for 0 to 10 or 10 and 2 inclusive 10? 0 to inclusive 10? Yeah, right? I thought that's what range was, but is that what index range means? Okay. Why does it like this? Oh, because that's in origin now, right? So really this is part how do we initialize it? Instance ingest. Oh, the part already exists? Wait, how did we call this then? Show call hierarchy. Oh, we put a none there. Oh, shoot. We're just gonna make it default to none, and then we could set it to something? Or yeah, because it's not until we start parsing. Well, hold on. Execute parse statement. I put that into here for some reason, right? Why was that? Because the part had to exist first before. No, well, why can't we just do some of this outside of that? Yeah, I had separated execute part statement and separated the ingest part out. It was because of this. We had to do that last, right? And this is just a refactoring of it. Yeah. But there's nothing that says I have to do this here. Yeah, there is. We need to keep it to insert it back into the keyed children. That's why. But was there a reason I needed part in order to do this stuff? It was because of the error. But okay, but I could have this return a result, and if the result is an error, then part.error equals true, right? Oh, I'm also not I'm not propagating the error up like I should be, right? go to call hierarchy. Yeah, I need to propagate the error correctly. Execute statement needs to return an error because execute statements needs to return an error so that ingest can set the error on the composite. Because execute statements doesn't take the composite. Don't actually know what the index type does? Yeah. It's one of those weird types that, what was it, Musin or someone? I can't remember who. Sarian, someone said that like the that range type really is sort of like it's less useful than you think it is because it was made early on in Rust and it's not exactly built right for generic use. It's more for a specific purpose in Rust. I decide not to put. Oh, it's optional. Hold on. Oh, it's in origin now. Yeah, okay, fixed it. Gonna have the same problem, right? Data dot um can I do this? Well, no, I'm gonna need the whole origin. I'll do this later. I'll do the other errors first. I was down here, right? Yeah. Yeah. This is composite dot origin dot ref. Some origin. Some origin. Okay. So yeah, I remember what it was. I don't want to set it in part. I wanted part to come with it. Right. I remember now this morning. If we couldn't, if there was some problem constructing the bound, we wanted to have a part without an origin. But I'm already baking it in that way, right? So I think it was it here? I would, you know what, I could just have the match construct the part, right? But okay, so I could have this return a part. Actually, that's the best thing to do, right? It would be let part equals that, and then we would construct it we would do all this construction. Actually, I guess we'd do all the construction at the very end. No, we'd do it up to here because we'd have to have the part to start ingesting into the part. Yeah, because we're building its parts. Okay, so it has to exist here. So all of this is to make it, right? Okay, I think I'm convincing myself that it's let part equal that, and instead of that, and then this part moves into here, but we're going to build it at the end here. So we're going to build what we need inside this huge match statement, and then we're going to actually construct it out here. And on these where these errors happen, I think I'm just going to unwrap it to be this with none, and the error is true. Yeah. Okay. So then if we have an error here, that's going to be a problem too, right? Shouldn't this whole thing be make build component then? I think it should be, yeah, we should have this all be into something called build component. Really, the ingest part is after we, this is like build and ingest, really. Copy and then paste and then end there. What happened there? How did that get indented? There, I fixed it. This should be like bill. This is ingest part. Actually, you know what? Ingest should take the format name and it should do this. This should actually be, this whole thing should be ingest. Because we could, from the very outer, we could make a UI. Yeah, I could. Yeah. So, okay, then I'm going to move this around too. And this is going to cease to exist. This is going to be build part. It's going to return this. Looks like I have some calls to kill. All delete. Okay. What's wrong with that? Mismatch types. Well, we're going to return it. Part. There. Chill. Good evening, gnarly quack. How goes it? It's rough right now. I've broken my library and I'm trying to fix it. Calls to kill sound like it showed just in time. Yeah. I went down this gnarly path of having a bunch of different lifetimes that we're juggling. And we're keeping one of them. Actually, this is going to change to a reference count in a little bit, but actually no, this isn't. Wait, why is that there? Yeah, anyway, so I'm killing off the path that I went down that was a dead end because I got in over my head with lifetimes. That happens, right? Dabble with Rust and you're not a master at it and you end up in a pit of lifetime despair. Yeah, this should move all the way out to the outer ingest function. This thing. Boundary is that. Yeah, we don't need to even build a context, right? Because it turned out we never used the context at all in these functions. There's nothing in here we need for an elemental. Yeah, we don't need any of this junk. That's not true. We need the boundary. We need that boundary. Okay, then there is a very thin layer to build a context that we still need. Okay, undo. So this builds a context on a default boundary, right? Where we map the origin to the whole length of the bitstream, and that is the boundary. Okay, so then this part goes into an outer ingest, and this part is where I want to paste there, because this goes in here. Exactly. That goes there. And instead of statement format, it's format name. These all borrow that context. Did I make that mutable? I did. I didn't need to for this though, right? That didn't need a mutable reference to the context. Yeah, okay, and it's composite, not part. There we go. Because we could pass at the top level a format name that's an elemental. It's only if it's non-elemental that we're going to execute statements, if we can find the format. And we're not handling that error yet, but we will. At the end, we need to clean up all the unwraps. Okay, but then this part needs to go into an outer function. And then the inner function will take an existing context. That's how I want to do it. So that's the inner, and we need to have an outer that, oh, sorry. That's the outer, and we have to have an inner that is, okay, so function ingest in context. That. No, that. Yes. Okay, and then this is in ingestion, so it's self. All of these are true, but we have a context. So do I put it after format name? Mutable context. And then this just does in self.ingest in context. All this stuff. There we go. And then we're going to do ingest in context down here where so this should, instead of ingest part, right? This should be ingest in context. Composite format name, composite. Oh, right. We're building it first, and then we're ingesting it. So build part. Build part doesn't take a part, it's making a part. So this goes away. We have, we don't need a part. Oh, we have a part statement. Ingest in context doesn't have a statement. It has a format, composite format. So that is what, statement format? Like that, I think. Okay, and there's no part there. The statement is already a borrow. Yeah, okay. What's wrong with that one? Cannot mutate immutable. Well, make it mutable. Okay, so we build a part, then we ingest it in context, and then we store it in the keyed children of the composite. Okay. And we have some errors here. Right, so I wanted this whole thing to generate this at the end, but first we're going to get no, that's not true. I want build to return a result with an ingest error alternative, and then ingestion error. And then this, instead of doing that crap because it's redundant, will return error. And then here's our opportunity to actually make a real ingestion error. But since that doesn't, there's no such ingestion, there's nothing in ingestion error yet. We're just filling in nothing for now. Okay. So the whole point of this match was to generate the origin, right? So this would be a none. This is an error. This is going to be a sum subset. Ooh, excuse me. Sum bitstream subset. Fill struct fields, enter. I wish it would do this for me. Okay, so we're going to compute these first. So instead of part dot, it's let. Let limit is the origins bit streams offset, and then this is origin this, and bitstream is origin bitstream clone. Okay, and then that's all these to-dos go away. Okay, it just doesn't agree with the type yet. Oh, it's okay, right? Actually, no. We have to say let origin equal, because that is one of the fundamental parts of the data component. Okay, so then what's wrong with that? Found enum option expected. Oh yeah, that's sum. Actually, it shouldn't be. There's no sum there. Okay, and then what's wrong with limit? Private. It needs to be public. Go back. All right, cool. So then if there's an origin and a bound, the limit's more complicated. We don't need to check this, right? Because we have an origin. This is wrong. Yeah, we already handled it up here. This must be really old code, so I didn't need this at all, right? So if we get a limit, then it's just limit. If we get an error, then it's return an ingestion error. After logging something, hopefully. It's probably logged inside evaluate expression. Okay, and then the offsets is calculated the same way. And so is the bit stream. Which makes me think I should, like, the way I should do this match. The way I should do this match is just do one level of the match and do the second level, like, well, I was trying to get rid of redundancy. I didn't want to have 3 matches. So I just have one match with a tuple, and we just do all 4 combinations. But these two are going to have the same calculation for offset and bitstream. I think it's fine. And they're actually going to do the same thing here. Maybe I should restructure this because there's too much redundancy, right? Okay. So that calculates the origin, which is an optional bitstream subset. Yeah, so then this should be origin. Can I not? Yeah. Well, actually, it's bitstream. That's wrong. Wait. We should be passing in the origin, not computing it from the bitstream. This is wrong. This needs to move out to wherever we would. I was doing this. Let's see. Where is this? There's another reference to these, right? The tests, I guess. Not there. Here, right? Yes. So here we should do this. Let origin equal. We always have a bit stream, so it's bits. That means we don't need to map. So then I don't need this stuff. This is origin. This is bits. Actually, then this needs to be a reference counted thing, right? Yes. Okay, bits limit and that, and get rid of that. Bitstream becomes bits. Import that. Okay, and yeah, so this has to be a RC. Is that right? It's it's just an RCB. RC is imported from standard RC. Something's wrong here. Oh, bit stream. Let's make it just call it bitstream, and that fixes this, right? Get rid of bitstream. Bits, I mean. Get rid of bits. Okay, and then the composite is this, so and here's just some origin. And fix this to actually take the optional origin. So bitstream subset of bitstream. Right? Yes, okay. And then we don't need to do this silly map anymore. We start with an origin. So this is much simpler then. It's like that. So should I have the error passed in too? Because in the error case, we're going to want to just say that it's true. We're not going to want to make it mutable, switch the error to true. Yeah, shouldn't we just begin with that? And we can just say error there. And let's sort. So O goes, whoops. O goes there, right? E comes for 4F. Okay, so E comes for 4F. We're all good. All right, cool. Back here. So this has to say, this is false. It's not an error. And we don't have to say let part. We're just building it at the end, right? Oh, we have to say okay. Getting there. So whenever I see errors go away, I get happy. Just in context, mutable data component. Okay, what's wrong with that then? Why is that a oh, right. Here, I wanted to like be able to shortcut out with these errors. But then yeah, build part still needs a part to put into the yeah, so it should be like unwrap or, right? Actually, that always would construct it. We want to do an unwrap or else. Unwrap or else we're going to make a data component new. The format is this. Error is true and origin is none. Actually, are all the error cases we don't have? Yeah, we have no bitstream for that error. This error is we couldn't evaluate the bound. Yeah, so in all these cases we can't clearly build the origin. You know what that means? That makes me think, if it wasn't for the fact that we're doing the arguments, then this should just be like building the origin out of the bound. But yeah, we're gonna have more things in here, right? Later. Yeah, we have to like have the arguments and we have to match it up with in the parse statement, it's got to have not in the parse statement, in actually wait a minute, hold on, maybe this is building an origin because we don't look at the formal arguments until we get to the format, right? It's not until we do this and then we get into this format, right? And that will have the formal argument list. Okay, so then shoot. We can't when we parse these arguments, we won't have the formal argument list yet. So we have to carry that around then. Where are we going to put that? Alongside here in the tuple? Jeez, that's clumsy. I suppose. Let me think about this. This ingesting context like looks up the format, right? And if that format, if we'd need these arguments early on, maybe we do this match early. No. I think I'm just gonna have to keep the arguments and the part separate until we get to here, and it just needs to be passed in. And then before we execute statements, and once we get the format and we get one, then we have to match up the arguments with the parameters and store them. So that's here, right? To do match up arguments with parameters here. That means we'll need the argument list. So why don't I just add that now? We know we're going to need it. And that means we're building not just a part, but we're also building a we're also getting its argument separate from the part. So we should probably have a structure for that. Actually, then I can actually make this the constructor of said thing, right? And then I can actually pass it in there. Okay, then that means what I want to do, I think, is maybe not here. It's all in this file, right? Ingestion. Let's make another type. Like right around here. Pub struct and like uningested data component. I don't know what to call it. And it's gonna have the data component. It's gonna be data component plus, right? So I guess that's not uningested. It's data component with arguments. Right? And then it's like component is this without the with arguments. And then arguments. And that's a vector of data values. Okay, and then that allows me to do an impl here on this. And then do pub. Actually, yeah, it has to be public because the outer one's got to make one of these to pass to ingest. And that actually allows the outer program to manufacture arguments if it needs to. So public function new. And it's going to be what this build part does. So let's just copy this. Okay, and then that goes up here. There. Paste. So I guess I do need, let's see if I can get away without the namespace thing. So there's no, oh, where is this ingestion? We don't need that, right? I don't think that build part ever used self. Yeah, it didn't. It didn't, which is another sign that it should go here anyway. So there's no self. We have a statement and we have a context. Why do we use the context for? We use the context to evaluate expressions. Okay, yeah, so we do need a context. Actually, then the outer one's gonna need a context too. But yeah, I guess we'll just I'll let context be wherever context. Where's context? I guess we'll just make this a public structure too. And this, well, actually, wait a minute. There's a chicken and the egg problem then, right? Can I make it an optional context? I'm thinking 2 steps ahead is what I'm doing. Let me close this off. We'll just mark this to do for a second. Yeah, I'm wondering, can I get away with that? No, it has to be named. Therefore, I must name it here. Therefore, I must name it there. Okay, yeah, okay, fine. So, back in the test, right? This right here, it does this ingest, which is a helper, and it builds an origin, right? And then it makes a composite, and then it makes an ingestion with about around those ASTs. I wonder if I can just, what if I just make ingestion and context the same class? Yeah, why not? Because they're like, formats are contextual, and so are like the so is the thing we're parsing, right? In fact, then that should go into the context. Oh, except for I wanted to move that into, okay, yeah. That's the problem. We wanted this. Yeah, this was a special outer one, but we wanted to get into this, right? We're ingesting something that's not yet built into the context, because context has a composite. Uh, is I get myself into trouble by like trying to do 3 or 4 things at once, and I shouldn't do this. But now I'm stuck. So I should probably do one thing at a time. What should that one thing be? This doesn't feel right because I want to be able to call this from the top level. Okay, let's put in here that it's not a composite, it's a component with arguments, right? So this is a mutable data component with arguments. It has a format. Wait, does the component remember its own format? It does. Then I don't need the format name because it's already in there. Okay. But is that correct? I think where I'm going with this is we need a context because execute statements needs a context because execute statement needs a context, and that context is used if the statement is a wait a minute. It's to evaluate these expressions, right? Wait, hold on. Shouldn't I be like forming a new context from this guy's boundaries at that point? Which is what I'm doing here. So this really should go into there. These two I think are coming together now. In fact, that makes sense because that is part of that. Okay. So it's really just ingest then. These two get combined. I don't know why I had these separate. Actually, I think I know. I remember why. It's when we're executing a part statement and we build a part based off of a current context. Then before we put the part into the composite, we need to ingest it, and we're trying to reuse the outer context, which is correct, right? Yeah. Okay, but if I combine context with the ingestion, then the outer one can. I know, we just make that optional, right? This we should construct when we do an ingestion new. This new, because we're given. Oh, actually, we're not. No, I think now I see why they were separate, because we wanted to be able to call ingestion multiple times. And it would basically form a new context every time based off of the bitstream that we have in the composite. Wait, that's not right. This thing would form a new composite every single time. Right? Yeah, it's forming a new one. Wait a minute. I think it's hard to see this stuff. So why are we making a new context there, but we're making a new origin there? This is too hard to think. It's too late at night. Problem is I don't know what I want. And I'm doing the outer shell and then the recursive call at the same time. I should just write here what makes sense. So right here, we want y past the same, all right, because we might want to have alternate ASTs on every call, right? I'm going to take a bit stream and have alternate. Actually, does that even make sense? Why would we have an alternate syntax tree for the same bit stream? Oh, because it might be a real-time stream and maybe we change the formats at some point. Okay, so then that means the only thing that retains state is this bits, which is why this should have always been immutable. I don't know. Yeah, we changed that to be immutable, but that's wrong. Because it fundamentally has to change the offset of that bit stream, right? Okay, and then this. Oh yeah. Shoot. Actually, that's okay. It's just we need to wrap this into an RC. So the let's bits equal that needs to say RC new that. making a statement that it's going to be reference counted, but this should be mutable. That's a double reference, isn't it? RC alone is not going to help me, is it? I need to look up RC again because I want to make sure that we can actually share things with it. Close that guy. Rust docs RC. Single-threaded reference counting pointer. We can put a new thing into an RC. We can call getMute if we have a mutable reference to an RC. If there are no other RC pointers to the same allocation, but we are gonna share them. So actually that means we can't put the bitstream. Why am I putting the bitstream in the composite in the first place? Oh, actually I remember why. It's because I might want to build super composites that have different bit streams later. Yeah, okay, that's why. So RC is not going to cut it. I think what I want is a handle. Well, we're going to have to do like an RC ref cell. There's no other way to do this, right? Or an arcmutex if we make it multi-threaded. Should I just assume it's single-threaded? Or should I just keep it open for it being multi-threaded? Or I can change the type later. Yeah, I think, okay. Yes, so then it's more than an RC. Close this. It's an RC ref cell. Interior mutability, and that means it is not a reference. Actually, I guess we can do this, but we're always going to clone it immediately. Yeah, okay. So this is going to be let bitstream equal bitstream clone. And then I have to get these while holding the ref cell open. So like this. How do we use the ref cell again? It's like, is it borrow? Can I do like a, I mean, I could do it this way, but it's gross though. Well, I guess it's not too bad. It's not too bad, right? Actually, what would be better would be to make a function that does that. This should say offset, not origin. If I made a function that did that, then Let me think about this. We need to clone it, but we only need to borrow it for a short time to get that stuff out. So what if we just made I was gonna say there's lots of ways you could do this, but fundamentally we're gonna have a tuple, or we're gonna have to destructure something to make this. Why don't we just make a new on bitstream subset? Yeah, what am I thinking? Impl that. Learning Rust by watching me develop this? I don't know if that's the best way to learn Rust. Is there ability to provide ideas here? That's fine. Just your moral support is helping me out tremendously. So public function new. So I want to do like what I'm doing here over in that new, just to, because I think it'll look cleaner. Okay, so like fundamentally we're gonna return a self, right? And let's see what we're doing here. So it's not a new, is it? It's like, oh no, it is a new. It's new from a bitstream. So yeah, it's like this, right? Shoot. Can I guess I will need to name the namespace. But we're planning to get rid, no, we're not planning to get rid of the namespace. We're keeping this. This is the only place where the bitstream is going to be. No, it's going to be elsewhere. All right. Anyway, yeah, so that's this. It's just self here, right? And then right there. Okay, almost there. Why won't it let me borrow? Because this needs to be an RC ref cell. Ref cell, import from cell. Okay, and then that infects this. I should probably have a new type for that, so I don't have to repeat it everywhere. So yeah, why don't we do that? So public type bitstream handle is that. Actually, there's the problem that I'm not going to be able to do this right. Can I do that? I can do that. Great. Because then that's what I want to do. I want that there. And there. Perfect. So we first clone the handle. Then we get the offset and limit by borrowing the bitstream to get its offset, calculate a limit, and then we're constructing it. Can I make that even simpler? Well, this is a temporary borrow. We're getting a ref, like one of these special ref types out, which is like it's borrowing it for some small lifetime, which is the scope of that, just to copy out the offset and limit so that we can assemble it. Okay, so I think this is fine because we button it away. We do that and we pretend that it's just good and we don't need to open it up. Just kidding. And then we can then call it in, where was it? In the tests, I think. So here is in, yeah, test dot. So here it would be let origin, actually it's just origin equals new bitstream. Like that. What's the difference here? Oh, we need to, what? It expected an RC, so we got to clone it. Yeah, we have to say, you get to own this. Actually, no, we're cloning it internally. Then this ought to just be that. And then I don't need to do that. It is a borrow. And actually, we don't. This doesn't need to be mutable. What's the problem? Type parameters must be constrained to match. B is a bit stream. Stream handle. It looks like it's constrained correctly to me. Did I not do that right? So is B a dyne bitstream? No, it's not. Ah, that's the problem. Dyne. Oh, shoot. That's not going to work. What did I do wrong here? Oh, it needs to come in as an RC ref cell, not as a reference here. So this has to be back. That is a reference. Yeah, okay, it's not generic. It can't be generic because we need to box. This says we're boxing it, so it's no longer generic, right? It has to come in boxed. So that is a dyne. Well, it's what I had written there. It's a dyne this. Dyne that plus that. And then it's not generic on B anymore. There we go. So origin is a bitstream subset. Data component new. The idea here is format origin and the error. So we say it's not erroneous to begin with. So here's the problem. Do I make the component and then ingest it, or do I make a context and fit this in there? No, this is what we want to ingest. So this is correct. Except for we shouldn't need to say that, because we've stuffed the format into there. So let's fix that. The format name doesn't need to be there because it's it doesn't need to be there either. That's because it's redundant, right? So what we're doing is we're matching component with args dot component dot format as slice, as a string slice. Don't need to do that. Okay, and then these. So wait, we don't need the arguments for these, so that's this much of it. So that goes there. With actually, why didn't it accept that? Because we have to borrow that mutably? Yes. Okay. Almost there. So if the format isn't an elemental, then we got to look it up in the ingestions format list, and then we'll handle the error later. We'll handle arguments later, because the arguments we're going to get from there. So then we're executing statements on so we have a context. Okay, why does it not like my context? Oh, because it's already a mutable reference, so it's just context. Okay, and so we execute statements, execute statement, all that good stuff. Execute a part statement. Here we go. So building a part can return an error. Oh, here's where I wanted bitstream component with arguments, because we have these arguments here, right? So we're going to data component. So that's the component. of something larger, right? Data component with arguments. And then the arguments. Is that not the right type? Expected vec found vec option. Vector of options? Why is that an option? Okay, turns it into an option. Okay, so we're gonna do unwrap for now. That should fix the bottom here. Yep. Okay, so what's going on inside here? Origin is a bitstream subset. Oh yeah, we gotta borrow. So let bitstream equal origin.bitstream dot borrow. And then this just becomes bitstream. Oh, wait a minute. Didn't I make a constructor for that? I think I did. So this should just be some bitstream subset new, right? From bit, yeah. It just takes a handle, which is this. Yeah. So I don't even need to borrow. Just do this. Easy. No? Can I find bitstream? It's origin dot bitstream, right? Borrowed. There we go. Okay, so this is the one that's more complicated because it has an unusual limit. I wonder if we could just bake that into the new. So right now, the new computes the limit as that. What if, like, that's just the default limit. What if I were able to like pass in a limit to override it? So then it would become like this, only we have like another argument, like some limit, right? Where we compute it from here. So then this would move, we don't need the offs, yeah, so it would go here, and we don't need this one. The U size. Sure. Yeah, and then we just do that. Okay, so I just need to update this. So we're gonna have like a limit, which is an option U size. Okay. So then we let this be equal to this, and so this limit would be, that's what we're gonna say. We're gonna say limit unwrap or that. So we're gonna take this, so this becomes the preferred, but if it's none, then the default is that. Okay, and then cool. So this has got to do a none. There's no limit. So use the default limit. Cool. Actually, then I could roll these two together, can't I? I can say, yeah, if I could roll these two together, and then, can I roll these two together? Let's see. I think I can. It's a statement ref. Actually, this just becomes bound, and then I can roll these together, right? Bound. So the answer would be to do this. If bound is some error, none. And then this is bound. And then bound just is used to compute the limit, right? So limit would be all this junk. Right, it would be bound dot map bound to all this junk. And then extra brace. So this just becomes bound. So bound is none, then limit's none. And so we're going to put limit here. Right? And just do that. Match. Why isn't it like my match? Try wrapping it in an OK. Because why? I don't know why. Map is something putting it into an option, right? So then that's putting into a sum, right? What's wrong here? Expected. Why is it expecting a result? Oh, because of that return. Okay, so then this is a problem, right? I need to move the and then out of this. Move that to there. That returns a result. Oh, there are two ways to get a result. That's okay. Yeah. If we have the bound, which is a borrowed expression, thing is, this is like the wrong way to do it, right? So I should probably just rewrite this. So if the bound is none, then limit will be none. If bound is something, then we want to evaluate it as an expression, and then like that, right? And then try. And then it's unwrap or, right? Well, no, I want to do that out here. Unwrap or, well, I can just say if it's an error, right? Actually, that means the match is out here. So we read it sort of like starting from here, right? That's an option expression. So if it's none, it'll be none. Otherwise, it's some error, right? No, it's going to put it into a sum. So it's going to be it's going to be option result. And then I'm going to want to transpose it. And then I'm going to want to, then the match goes out there. Like that. Okay, I think I got it. It's really complicated though. So the bound could be none. If it's none, then it's okay. Sorry. Right. If it's none, then an option result of none turns into an okay none, right? So it'll be okay none. Yeah, transpose is weird. Yeah, see, like if it's a none, it becomes it generates an okay. None is okay. I always forget this, because usually I think about it from turning a result option to an option result, but there's actually two transposes, right? There's a transpose for option result. Yeah, option result turns into result option, but you can also turn the result option into an option result. I think I'm used to using the other one. So yeah, if it's none, it becomes an okay none, which now this will unwrap it. But if it is something, then it will map that something, an expression, to evaluate the expression, and then try to convert it. So either one can generate an error, right? So we'll have some value, or we'll either have some value or some error. Then it becomes either an okay value, right? Can we get an... Yeah, if it goes in here at all, it'll be some, so that it'll either be an error or it'll be okay something. Okay, yeah. Gosh, this is really hard to... I mean, it looks pretty, but it's really hard to think about. There's probably a better way to write that. But I can't think of it right now. Actually, can I combine all of these together? No, these are fundamentally different. This one, we don't allow a bound. This one, the bound is optional. Yeah, so these are completely different. Although the fact that I had to repeat that means there's probably another way to reorganize this, right? There is. I just need to say let bound equal this. And then I don't have to have a tuple. I just say I guess we're still doing a match because none is actually we have to do something with none. So we don't want to do a map. There we go. Now we get to outdent once. So we get the bound. And then we check the origin. If the origin is nothing, then we make sure that there is no bound. Otherwise, if it's some origin, then we figure out the limit and we make a bit stream, and that becomes the origin. Okay, can I reduce this even more? I don't think so. Because this is going to become an option anyway. It's not a map exactly. We'll just leave it. Maybe Clippy will tell me how I can make it better. Okay, we're just moving on. Okay, this is no longer true. We actually do need to collect it. Actually, I guess we could wait to collect. No, the statement, we only have the statement as long as build part runs, right? Then we don't use the statement anymore. We do ingest. We don't have we're just extracting the statement out. We don't pass the statement through. So this is sort of consuming the statement's arguments and then evaluating the expressions in place. Yeah, so we're going to collect anyway. So we're going to get rid of that to do because we end up packaging the arguments here. Good night, gnarly quack. Don't forget, a fresh day always helps give a fresh perspective. Yeah. I think I'm on a good track here. Okay, so it turns out we didn't need that format name because it's in the part, right? Yeah, look at that. Ingest is correct. Just ingest it. So we have to do like a borrow dot length to get that, right? Yeah, and then we could provide args here. Did I not want to? I guess we should. So this should change to this. Yeah, it's this in front of that. So when I pull it apart like that, component. It's, oh wait, that's the problem, right? What do I put for the context then? I think this composite needs to be optional. Because at the top level, there is no composite, right? The top level format is just parsed in a global context where it doesn't, we can't reference anything other than it itself. I just thought of something. How when we evaluate expressions and we're following references, right? How are we gonna have it look into itself? Yeah, like the format. When we like, how do we? Yeah, when we define a signature and then we immediately reference it, that's from a different statement. No, this would work, right? What if header was top level? I'm getting a little bit lost. Yeah, I think this is actually how we have to do it. So that means that this doesn't actually take that. It just takes the arguments, right? Okay, so where is this called from? And then here, okay, here's the crucial thing. So let's say that, yeah, actually, don't we form a new context in here always? No, we don't. The reason is we're just ingesting a part. So this should really be ingest part. Okay, the name would actually help me. Ingest part. Thing is, that's not the right call, right? It's not that. But we still have to do this stuff. So at the top level, what is the context? There's a chicken and the egg problem here. Yeah, I was thinking maybe if we made that an option, then at the top level it would be a none, right? Is that the answer here? It would be none. Then I make it constructible, and then there's just ingest. So I think that's the answer, is this is just up to the user to do, and there's just ingest, and we take a context which doesn't have a larger component. Okay, then here we have to actually form a new context, don't we? These are not contextual at all, right? I think that's also throwing me off. Yeah, okay, I think I might know what to do here. Yeah, this component we're gonna put in. Yeah, because we're gonna separate the args and the component here, and the component goes into a new context. So that means this part actually goes into here, right here. I think this is actually where it started. And then that goes away. So then this actually becomes context composite. Bedtime soon. Takes yeah, I think this is going back to where it was. How come it keeps clicking? Okay. Component origin map, borrow its length. Yeah, then this just becomes ingest. Okay, where is this called from again? Let me see that. This thing. This part statement here. Okay. So there is no context in Oh, wait. We do form a new context, but we need an outer we need at some point we need to have an outer context, and then we take it to a inner context. Yeah. The outer context is optional. When we execute a part statement, this is the outer. Or that has the outer and it's the context around it. So ingest should take that context, but it's the outer context. This is the inner context. Okay, so we have an outer context. And I don't remember if do I need to mutate this thing? No. Well, hold on. A part doesn't when we ingest a part, it doesn't modify the the context for it, right? It's going to form its own inner context from that. Just yeah, okay. So then this just takes a context. Okay, and then this is an inner context. And don't I just take the outer context boundary and then this really, that's just the default outer context? Yeah, actually that should go in my tests.h.rs. That should go here. Yeah. So it's composite. Actually, it's just origin. And we don't even need to do an as ref, right? Actually, the types are weird here. I'll come back to this one. I'll come back to that one. Yeah, I'll fix all that. I'll fix all of it. I swear. Yeah, the boundary should be inherited from the outer context boundary. The composite is the component. So that's an option. And this is non-optional, right? So sum. And we have to use a reference count here, right? No, we can't. No, we don't. What's in here? It's owned. It is owned. Oh, yeah, then we just do this, right? Mute. Yeah, okay. Then what's wrong with that? Oh, shoot. So it wants a component, we gave it an option. Well, actually, then if we're passing the inner context, it can get the composite. So this is all meaningless. Let's just delete all these. Delete. So there is no context. It's just the data. Yeah. The component has, actually, no, it's not, sorry, it's the other way around. There's just a context. Right? Yeah, yeah, exactly. The elementals are directly ingest the composite. It's if it's not an elemental, then the composite's made of its parts. Yeah, okay, so then it's the context we give it. So these all have to take the it has to be mutable. Yeah, so then we have to make sure that there is a component in there, and then that component has to have an origin. Yeah, so there's several levels here. So let some component or some data, I guess, equal context dot composite. It's an option. I guess then we do this. Error count. What do we print here? without a component, without without a place to store the value. Yeah, without composite. Feels weird. In fact, there's no error to actually set. It would just do an error and return. Mute. Right, so this is like another level, right? Or it's actually more like this, origin. Why doesn't it letting me double click that? Origin equals this origin. And then let the bit stream equal origin dot, oh, but there's a limit. There's a limit. So we don't want to use the bit stream's length. Borrow mute. Because then we can do this stuff. Wait, what's the problem here? Cannot mutate. Yeah, this. So we can't do borrow. We have to do. Oh no, we can do a borrow. Guess it's a ref. Wait, what? So why would I ever do a borrow mute? Mutably borrows the wrapped value, borrow less until. Yeah, but how am I getting away with just borrow and making it mutable? That doesn't seem right. I'm gonna go with it. Okay, so we're just gonna copy all this stuff to make all these other ones work. This. Yeah, but I don't want to use the length, right? I want to use the origins limit. I have to be really careful about this because limit is the number of bits left, counting from the first bit which makes up the data of this component, right? But bitstream subset has no component, so this makes no sense. Okay, yeah, we'll get back to that. I'll just leave it the way it is. I know what I'll do. I'll let the unit tests get this building, get this proven out for me. D. Okay. Yeah, all these kind of work the same way. You have to have composite, you have to have a bit stream. Okay. Context, mute, no data, mute, no data. Okay, what's up here? So in the context, we have the composite. So, right, we only do this if, so the reference only works if there is a composite. If there's no composite, then yeah, it would just, so let composite equal self dot composite else, and this is just composite then. So we got an error here, right? Well, let's just unfold it for now. Yeah, we'll just fold it, unfold it for now. Unwrap. Self.composite unwrap. Deal with that later. Okay. 55 errors to go. Oh yeah, these all have to be mutable. Mutable. So if these all take the context, and this context is always sum, then it's impossible to enter it. This is impossible. So maybe I just do an unwrap. So I'm thinking like the most elementary case would be the component format is UI. We take that component and we put it in as the composite, and we're not using the outer context at all. Does that make sense? I think so. These don't need text evaluating expressions. Wait, how do we get access to the... I just thought of something. This isn't gonna really work very well, is it? We're gonna lose the outer context. We're only doing it to get the boundary. Shit. Oh no, this is okay. In fact, I think I just convinced myself I only need to pass a boundary, not an outer context. No, there needs to be a context. Because execute statements, again, calls execute statement, which execute parse statement, and it's going to ingest, and we're going to want to pass the context along. That's how we evaluate expressions. Wait, where are the arguments? Oh, that's part with arguments. So what's wrong with ingest? Oh, we didn't need to pass the format because it's built, it grabbed it from the statement. And then wait, take 0 arguments? Unwrap or else the F. Oh, it takes the error? If it's an error, then wait, what? What am I doing here? Oh, right, because we might want to take that error and put it in here somewhere. So we actually don't need that error. It's just turning into an error flag there. Okay. It's supposed to be data component with args. Humans. Did that have a new? It did have a new. It needs a statement and a context. What? What the heck? No, that's how we were calling it down there, right? Right here. No, say, wait, why did I have a new on here? Oh, was I planning to move build part? I think I was planning to make build part just actually do that. But I need to build a part anyway, don't I? Wait. Oh, I was in the middle of changing this. Damn it. It is just a component. Yeah, so this is just a part. This will already like wrap. Hold on. No, it's with the arguments. The arguments are there because part of the ingest is to match up the arguments. Okay. So what do I do if it's an error? I'm not going to ingest it, right? I'm still going to insert it. So then, isn't it just like a dot map then? Yeah. This is actually part. Well, hold on. We'll need to do a map here first. And there's not an unwrap or else. That's at the end. So there's a map here. Map part with args. And inside there goes all this stuff. This goes there because ingest doesn't return anything, but it does. Yeah, we're going to ingest it and then return just the part out of it. So it's going to be the part with args. Actually, that means shouldn't ingest if we're splitting it out, this should return the part. So then this consumes the data with arguments. And it returns just the data component. So we get back out component with args dot component there. Blah, blah, blah. What? Why is this because this is not mutable? Okay, now it's mutable. Okay. Then going back to references. Clean this up. So it gets consumed and turned into a part. Otherwise, we're making just an error. And that is like that. So this is just part then. Let's just takes a slice. Okay. Okay, so again, context is optional, right? Does it make sense to execute a parse statement when we don't have a composite? It's back to that ingest thing again, right? This outer context, inner context crap that I was trying to figure out. I gotta figure that out though. Yeah, it doesn't make any sense for the composite to be optional in a context. It's always going to be that. So I'm pushing back there. If I push back there, then I'm not unwrapping here. These go away because then it's just data is context composite. Shoot. So let's just do let data equal context composite. Yeah. Irrefutable. All right, and then yes, we're letting it mutably borrow the component. Okay. Wait, what's that doing there? Is this old? Yeah, this is old. This gets deleted. Finally. Ingestion builds, but what's not building? The tests? Okay, all right. We gotta fix this, right? So what does ingest want? Component with arguments and an outer context. So it all comes down to this. When we're ingesting something, we expect a context. Yes. So let's just call it what it is. This is the context. Context. These should all take the context. So like this inner context really only applies. Wait, yeah, then hold on. Let's comment that out for a second. If we comment that out, then all of these become just context. And it's starting to look good, only this has to be mutable. And then these all go away. Okay, we're almost there. It's just that and so that it's just that the outermost call in tests has to be made a certain way. Does this look correct? That we're executing the part statement. We build a part from the current context, which is used to evaluate expressions. That's correct. So the context has a composite in it. We're building a part of that composite. I think I probably lost everyone who's watching. You know, that's okay. The 30 people who are here probably are just here listen to the sound of my voice, right? Or you're just rooting for me that yes, he'll eventually get this working again. I go through these like low points in the stream every year when I do these projects where I'm so laser focused on a design, the guts of the design where it really proves it out, and if it's not all correct, then it's a big mess, and then I spend like several streams cleaning up that mess. But in the end, it's all nice and beautiful, and it works, and I make something like this, right? And it just works. I think we're in that rough spot in the project right now. D thought today didn't want to break my flow. Yeah, well, like Gnarly Quack said, like when I'm in these like the hardest part of the project, it does help to take a break for fresh perspective. The problem I have is that the last 3 streams have been like this. So I really want to like do that final push to get through this. And then it's all going to be payoff from that point, right? That's what I'm thinking. Okay, question I have is, do I want to stay up and try to do this, or do I have to get up early? Like, do I have a meeting tomorrow early? I do, but I'm going to take that meeting from home. Okay. Okay. I should put that over here. All right. I think I'm going to push through and get this working. We're going to do it, even if I have to stay up all night to do it. Famous last words, right? Okay, so when this calls, what am I looking at? This is building apart from a context, right. And then we're ingesting that part. This is where I gotta be careful here, right? Because ingest assumes that this is an outer context, right? No, it's the same. We're ingesting the component that's in there. So this doesn't go there, does it? Here's where we need to make the inner context. Exactly here. Right here. So right here, we need to form an internal context to ingest the. Wait a minute. Okay, I think this is where it goes, but I'm not 100% sure. I want to go back to the caller of this. Here. Okay. Actually, it's a chain, right? This doesn't feel right, actually. Sometimes not about pushing through, but setting boundaries for yourself. Yeah, I have a tendency to push boundaries. Okay, if I keep ingest the way it is, then this is correct. Because when we're ingesting the part, we're going to execute statements in its format. Actually, no, that's not right. Maybe it's inside of here that we form an inner context. So that would, yeah. I think this goes here. So we're gonna make an inner context. Actually, I guess that means that ingest, no, it just takes a reference because where it's called, yeah, it's always gonna take a reference. Right, so here's where, yeah, I was doing that correctly, right? And the boundaries inherited. Figure out the arguments. Split the arguments from the component. Okay. from the very top level, this is wrong because we haven't, because this is wrong. These don't add up. These don't match each other. I'm going, yeah, okay. I almost need to have that on the same screen as that. That and that on the same screen so I can look at them side by side. I think what it is I'm trying to make one function usable from two levels, and there really needs to be two functions, and I tried to do that and it didn't quite work, and so I thought it made sense to go back to one function, but really there should be two. Where do I make a new context from an old context? It's when we are in a composite, like maybe it would help for me to have the format in front of me. So the outer thing is going to form a context, and it's going to say that it's GIF format, and it's going to say go ingest it, right? And then, because if it said the outer actually no, it's not going to say that actually. It's going to give a bit stream, and it's going to say parse the next thing as a GIF. And then we're going to look up GIF and see this and execute its statements, right? And then when we hit a statement like header, we'll be in a context of a GIF. And header will be added to GIF. Okay, that does help. So then at the outer level here, we're making a bitstream. I actually don't even think we need this bitstream subset. It's just bitstream. Well, it's a bitstream, and then we might have a limit to it and an offset. Yeah, that's true. Have you tried diagramming it? Nope. I might do that if I get really, really stuck. You can drag the tabs to the side by side, maybe top to bottom. It's also a constant struggle for you because you're blind as a kite. Yeah, I was playing around with bookmarks last week for that, and I could flip between the bookmarks. But I think I'm good now. Why is this an error again? It takes two arguments, but one is supplied because the other argument was a limit. Oh, because I said we just need to make this a none, right? No limit. Okay, so we make the origin of the thing, and then the composite is we basically build a new one, which has a bitstream and a format. And then did we? We didn't have to make. I don't think we should need to make a context. We should just say ingest this thing. So if that thing has statements and the statements have references in them, well, the first thing we should do in ingest is this thing should become, we should build the context out of that. Yeah, okay, so then we don't need this boundary crap. That's built into this subset anyway. We have that limit, right? Yeah, we're not doing that. We're just ingesting that composite. Okay. And I said that it could have arguments, right? And that makes sense because, yeah, we might have arguments. Yeah, exactly. We might have arguments, but it won't have a context. So I do need to form one with arguments. And I think we're just going to use this form. So component, data component, new, and then arguments is empty vector. Import. There we go. What's the error though? Component. Yeah. It's private. Well, let's fix that. Public. Okay, and then ingest should not have a context. So I think we are going to two functions because there's one that starts with no context and we build a context out of that. And the second one uses a context given to it. So let's call this one ingest in context. And then this one's just ingest. Okay. Either way, it's going to return a component, so I should go back to tests and say that it's doing that and it takes that. This doesn't need to be mutable then. There we go. So it returns the data component like so. Okay. So then what if we say parse the next bits as a UI? Well, I think here's where we form the context then. So let's just take this, form the context on it. Let the context be, we take out the component and we need its boundary. We need a boundary. The component has a bitstream in it, right? No, it doesn't. Oh, I forgot about that. Yeah, we never, oh no, we put it into the, it is there. Yeah, okay, it's there. There it is. All right. So we just need to get access to it here very briefly, right? So like let boundary equal component with args, component, origin. This boundary is optional, right? Yeah. So origin dot map to origin dot limit, right? I thought I had to oh, it's the bitstream handle that is has interior mutability. Right, okay. Then that's boundary. Okay, and then these borrow the context again. Okay, so is this right? We would form a context. I think we should have the outer ingest call the inner ingest, but here's where I got into trouble last time. So if we make a context where the thing we're ingesting is now the composite, and we call an inner one, we need to call it the same way that it would be called from the other place. So let's go down there. This is ingest in context, right? So the way we would call it if it was a part is there is an outer and now there's an inner. Outer, inner. So if we leave this the way it is, then how do I call it here? Would I just, maybe I have to repeat this twice. Because the outer could be an elemental, or maybe we just don't let the outer be an no. We should allow the outer to be an elemental. So maybe we just have some duplication here. But okay, the crucial difference here is we do not want to form an inner context because we already have a context. We're just parsing the statements of the part within that context, right? No. We do make an inner context there, but we don't here. Yeah, that's the difference, right? Yep, that's the difference. So this is just the context. There's only one context that has our component in it. But this one we have to make an inner one. And that's because we have a component. Yeah, and we have to inherit a boundary there. I think this is what I gotta do, but there's some redundancy here. I need to kill the redundancy. Granted, they don't fly in clouds, but who would be flying them in bad weather? What does blind as a kite mean? I thought it was blind as a bat. Because bats can't see so well. They use echolocation. Is a kite and you mean like the bird also blind as a bat? Pretty much the same thing? Okay, maybe I solve the other errors first and then try to handle this redundancy. Okay, let me just think. Is this correct? So top level, it would fill in these fill in the value of the composites, right? The data is the composite, right? So if it's an elemental, it works. What if it's not? What if it's like foo? Then it would execute the statements of foo within the context, and the context has our component in it. So that's correct. Okay, so execute statements of foo, statement, and let's say we get to a part of foo, like the header. Then we would build the header, and the context still has foo in it. We would ingest like header in the context of foo. Oh, this is wrong then. We have to do this at the top, after all. And that's because these take the inner context, actually. But let's say it's a header. So we make an inner context with header and a certain boundary. And we're executing the statements of header. Yeah, I think this is correct. Wait, didn't I just make the same thing? They're slightly different. One, the boundary comes from the component's limit, the limit of the component's origin. The other one, it's just an inherited boundary. Okay, but after that, they're the same, right? So there's a third function then. So yeah, I see. So rather than trying to combine this into one function, there are really three functions, because that is different from that, but then this is all the same, right? I think so. So then, yeah, we're gonna refactor this. So it's going to be it's not in context, is it? Is this ingest part then? I think it is. This is ingest part, and then the third one is ingest in context. Yep, I think that's what it is. So we return ingest in context. This is self.ingest in context. Yeah, and actually we have to actually get the format out, because we have to get the format and the arguments out because we already pulled out the component. So it would be the context first. And actually here, it can own it. So inner context. And then we're going to pull out the arguments. So component with args dot arguments. And it's also going to own it. So, and then the third thing is the format, right? So that's, I guess we should pull that out first. Let format equal that format. And we just need a slice of that, right? Actually, is it gonna let me do this? I don't know. I think it let me do that before, so let's just try it. Okay, and then we're gonna write this down here. So this is ingest in context. Context first, then the arguments, which is so this is owned. This is, actually, is the top one owned too? Yeah, it's owned. Okay. So then this is a vector of, what did I call them? It's whatever this is. Vector of data values. And then the format, which is a string. Okay. And then, so we match the format. This is always context. We don't need to do an string. We get with the, well, format name is just format. Okay. And then we're returning the context component, right? Context composite. Is that actually, that's a reference though. Hold on. Hold on. It came from, yeah, I guess we don't return anything because we already still have it. There. And then this upper one here will do something similar. Okay, so then this one doesn't return anything. It's just ingesting. Okay. Why did, oh, mutable. Okay. So then I just need to call this self-ingesting context correctly from here, right? So this is context. It's still component with arguments. Actually, yes. And then we have to extract the format out the same way. Yep. And returning the component when we're done. Okay, I think I did it. So top level, we just have a component with arguments. There's no context. It's context free. Get the format. The boundary comes from the bit streams limit, and then we form a context with our new component that we just made. No, that we were passed in. So we have to start with one. The outer is going to have to create one, and then the boundary, and then that's the context that we're going to ingest. So we ingest it in context and return the component. Now, if we're doing a part, now we have an outer context like a GIF file, and we're ingesting a part here, component. Yeah. So this is like the part with arguments. And getting the format. And then we're making an inner context because we're going to, from here on, we're going to ingest that, yeah, the part becomes a smaller composite. Passing these things. So then in context, that's the thing we're ingesting. Whether it's an outer thing or a part, it could be an elemental or it could have statements in it. And then, yeah, okay, I think this is it. All right. You admire capable Rust coders. There's so much as something else. Boo, self, unwrap. You can't fathom what's happening or even what's tried. Yeah, there's a bunch of jargon in here, like as str. If I show, sometimes when I show the inlay hints, it gives a little bit of information. So like it'll say that as str returns a reference to a string, so it's like a pointer to characters along with a length. But yeah, it's pretty obscure because it's so compact, right? Like these have meaning. Like if I chase this all the way down, oh, what's that still doing there? These shouldn't go here. Oh, wait. Now that we can get rid of this namespace now. Cool. That's excellent. So yeah, I actually don't even need that. Wait. How did this work with buffered bitstream then? It has a it has a lifetime, right? It has a lifetime based off of that. I guess it works because we can do that. Okay. That's cool. How did we get away with doing that? I don't know. Yeah, isn't it gonna come it's ultimately okay, I shouldn't do this because ultimately it's gonna complain in my outer that we can't stuff a life something with a borrow in there, right? So I should go back and undo all the stuff I was just doing. Or at least wait until the end. So I should leave that there, right? I should leave it alone, not touch it. Okay. So leave that there. Okay, I'm not touching it anymore. Lifetimes have little tick marks. There are no namespace in Rust. Not really. Okay, where are my big errors? There's in the tests. Those are all my tests. Oh, cool. Okay, so then the library's done. I just need to make the tests work. Okay. How did this work? Um, I had got one test to work, right? Where was it? It was ingest. Yeah. So, how did I make this work again? I think I was trying to get this to work, right? Ingest takes a bit stream. Oh, right. So this had to be we had to make this a ref cell new. We had to put it into a ref cell because we plan to share it. And then ingest just borrows the ref cell. But why does it not like it? Found ref cell. Oh, it's the life. Wait a second. Buffered bitstream, and it wants a dyn. Oh, we need to box it. Shoot. How do we do that? Wait. How do I put a dyn in a ref cell? I don't know how to do that. Do I write nice Rust? Can't say the same for other code you've seen. Well, I think what happens is sometimes people write Rust that's so compact that it's just hard to decipher. I like to give long names to things. Okay, so there's a problem is I don't know how to actually make one of these right now. Like I know how to do it with box. You do box new and you can pass something concrete. But I don't know how to do it with ref cell. Like it doesn't like that type. And there's no way to change it, right? How do I do that? Is it because it doesn't implement the trait correctly? No, it does, right? Implements bitstream for buffered bitstream. Do I put dyn in front? No. How do I make it? Let's look it up. Rust. Construct. Ref cell trait object. Here we go. How do I cast a concrete object in a RCR cell to a dynamic? So someone's asked me this, but it got a -1 because it's already been answered here. Trying to cast RCRF cell data into RC. Yeah, exactly. This is exactly the question I have. So how do you do it? What's the biggest answer? Many thanks. I understand the solutions are clone as what? Oh, you just cast it. Huh. Okay. So we just do that as reference to RC ref cell dyn. Well, I have to type a lot. Can I just go back? See if this just works. Do I have to put a name there? I don't know what to do here. Just do that. What's the problem? Non-primitive cast. As can only be used to convert between primitive types or coerce to a specific trait object. That's what I want to do. I want to coerce it to a trait object. Okay, what was the solution? RC ref cell dyn interface. RC ref cell dyn. Is it that I have that in front? Okay, what if I do it this way? Let the bits equal bits as that. Can I do that? Yes, I can. Okay, then can I do at bits for there? I did it. So how do I fit that into that? Where do I, can I put that in parentheses? Oh, I can. Oh, that's ugly. Okay. Can I instead of doing that, can I just like do that? I can. Okay, that's what I'm gonna do then. So right after we do a new on it, we're gonna cast it immediately. It didn't like that. Why not? Because it doesn't know what the type is. It would do that and it should work, right? No? RC, okay, so we forgot the ref cell part. I'm kind of distressed that it's not formatting it. Shouldn't it like break that line into two? Oh, it's really confused. Shoot. How do I fix that? Maybe it's because it just doesn't compile yet. I hope so. That, and then like all of this, right? Okay, and then one more. That and that there. And then all the mutes go away. I guess it didn't matter that we made it mutable. That? No? Hold on, what did I do wrong there? I don't see what I did wrong there. Oh, is that it? That was it. I need another parentheses there. Okay, and then formatted it, and we're down to 9 errors in other files. That's good. That's good, that's good. Right, because bit has its own test. I think we're on our way to getting this working. That's RC new, ref cell new, that. Get rid of the mutt. One more parentheses. Okay, and then this doesn't actually need to be mutable, right? Okay. It's not mutable anywhere here. Good. 5 errors. Getting there. Okay. Magic. This is the magic sequence to make a ref celled. That's interesting. I didn't know that like you could do that kind of a cast as that, right? RC new ref cell new that. No mutts allowed. Okay, and then repeat. That to there. And then this in front. No mutt. Three errors. Yep, it's just the other tests. Okay, we're on the home stretch. Of course, this is gonna horribly break in my tests, but that's fine. It's been like several streams since I got this to compile. Ref cell new. Get rid of the mutts. Actually, how many tests do I ever? Okay, just one more. So copy, paste, copy, paste. Get rid of mutts. One error. One error. Paste, and then let's go back and do a copy of that much. Forward, I say. It doesn't know how to go forward. Okay. Paste. Get rid of mutts. Oh, now we have 14 more errors. It was too good to be true, chat. Okay, what did we do wrong here? Don't tell me it has something to do with lifetimes. Oh, it's like all the places that we get into. All right, right. I remember this. That had to be borrow mutt, right? Yeah. I was wondering why I got away with that before. We have to do a borrow mutt whenever we're getting access to the bitstream. So that's a borrow mutt. Borrow mutt. Borrow mutt. Actually, that. What's wrong with that? It's borrowed as mutable where? What? I don't see that. Does length? Wait, what? It occurs on line 100. Used later in the call. Try adding a what? Why does it want me to do that? I didn't have to do that up here, did I? Or down there? Maybe I did. Borrow mutt. I'm confused. Why does it need me to make that a local? Okay, we'll just set let limit equal that. Okay, and then just put limit there. Why does it need me to do that? I don't know. I thought that returning a value would just do a copy. Okay, fine, whatever. Whatever. Okay. Cannot borrow it as mutable because always borrowed as immutable and occurs on 171. Okay, yeah. Yeah, I remember seeing this thinking, how are we getting away with that? So we're not. Um, when we do that, that's exclusive access. But what are we doing with that format? We're passing it in separately. We don't need to because it always comes. It's always buried in there. So I think I just need to get rid of that argument. Yeah, it's always in the context, right? Or is it? Format. It's not. No, it is. It is. Yeah, we can just put that in the inner down in here. I don't use the format for anything else, do I? Yeah, I can just do that. Context dot composite dot format dot as string, and then we don't need to pass the format. We get rid of that. Get rid of that. Get rid of that. Okay. Does not live long enough. Borrowed value does not live long enough. It's dropped while still borrowed. Why is it dropped while still borrowed? That, can I just say drop context? We don't need it anymore when we get to there. Why can't we drop the context? Context has been moved? Oh. We moved it in. It's consumed there. Okay, so then we really can't move it in. We'll just borrow it mutably. That moves to the right-hand side, right? And then, yeah, we'll just get rid of these. That's actually cleaner. Okay, so this borrows mutably that. And this also borrows mutably. And then I don't need to drop the context, right? Okay, is this because it's in the context now? So I can just say context.composite? Oh, that's a mutable reference. Hold on. So I do need to drop the context. Wait, then what the heck? I dropped it. Why is it saying it's been moved? No, it's not borrowed. Borrow occurs there, but I dropped it. Oh, is it because of the lifetime? Yeah, it's this lifetime. Can we get rid of that? Can't get rid of that. But I can borrow it for a shorter time, right? I'll get back to that one. It's the same problem there. Yeah, I know we're not using the arguments there. What's wrong with this? Explicit lifetime required in the type of context. Lifetime bitstream is required. Context. Here? What the heck? Card. That's what I did. Oh. That. Do I need that then? No, I just needed it there. Okay, then we're down to these 7 errors. Any other modules we have errors in? Nope. We have an unused variable because I haven't implemented that. Okay, so it's all in ingestion. It's these 7 errors. Okay, and it has to do with the lifetime. Okay. We know we're going to drop the context, so I want to see if I can get away with, like, context. And then borrow this for a smaller lifetime. Context. Oh, now we're just down to 1 error. And it needs a lifetime. That's context. Oh, now we're back up to 4 errors. What's this problem? Moved value. Move occurs because origin has a type offset, which doesn't. Okay, so the component got moved out somehow. Oh, we moved it in here. I think the arguments. No. Move occurs because the origin has a type option. Move due to the method call line 170. It got moved here. Oh yeah, we don't want to do. We just want to do as ref here. There we go, fixed it. Okay. What the heck? I get all these errors. Cannot borrow key children is mutable more than once. Okay. Probably because of all this junk here, right? Argument requires that context is borrowed for, okay, it has to do with these lifetimes, right? Context and bitstream. Figure that one out. Okay, that made it a little bit better. Now what's wrong with this? Closure requires unique access to context, but it's already borrowed. Oh, in build part? Yeah, so build part. It just borrows the context though. Why does it think it has a problem? Hold on. Borrow occurs in 290. Second borrow occurs due to use of context in closure. I see that, actually. Do I just make another local to solve that? I think so. Yeah, I think it's because the borrow extends all the way to the end of the statement. But if I take this out, if I say like let part equal that, and that's like a maybe part, and then let part equal part dot map. No. Closure. It still thinks the borrow is active. Is it because of this? I have to say that. Did that solve it? No, it made it worse. Okay. Let me back this change out for just a minute. Because it should be able to figure this out, right? It might not live long enough because I need to turn my fan off. Lifetime may not live long enough. Argument 1 requires that 1 must outlive 2. Clear. Let's see it. Lifetime may not live long enough. Let's call this 1. And then 2 is the context borrow. Wait, hold on. Why does that type have there? Oh, because that's in there. Okay, that makes sense. So the context actually borrows a composite. I wonder if we need to borrow it. Maybe we move it in and then move it back out. Would that make more sense? Can I move it in and then move it back out? That I should be able to do that, right? Because let's see if I can do that. So then let's remove that and then just say that actually it's a part of it. Okay. Then we don't have this. And then we're down to 2 errors because these don't exist anymore. Get rid of that. That causes 3 errors up here. Right. So here we're going to move it in and then move it back out. Move it in, and then it becomes context composite on the way out. Okay, that solved it. Okay, cool. So then move it in, and then move it back out. Inner context.composite. 1 error. Here. Hold on a second. What did she do?
She got in the garage and now she wants food. Yeah. Oh, I thought you were streaming.
Yeah, but she won't get in front of the camera.
Oh, okay.
I need to finish up and go to bed.
Okay.
I'll let her
I'm gonna go
haunt
to
me.
bed also.
Okay.
When you go up, I have a thing in it.
Hold on a sec. It's picking up your voice for some reason. All right. Sorry about that. Yeah, well, we're almost there, down to one error. What's that one error? Cannot be dereferenced because we own it, right? Yeah. So then we do that. Now we're back to 3 errors. Because we... Wait, what? We actually don't have this, right? Yeah, this doesn't exist right now. Let's just delete that. Okay. Private context and public interface. Oh, this shouldn't be a public interface. Yeah, okay, and it doesn't need to be mutable anymore because we essentially own it. Okay, and this is the same thing, right? Oh, no errors. We're out of errors. And we don't have a bit stream. We only have warnings. Ooh, first time we can test and see everything crash, right? It's gonna like utterly fail and blow up, isn't it? Because I haven't run this in several streams. Building the parser, and then we get, yep, we're failing every, well, we passed 7 tests. Oh, wow. So we can actually parse some things, but that's interesting. The simple format failed. Whoops. I, um, I'm surprised. I'm surprised it actually got so far. So it saw an 18 for a bound of 4. Okay. So this test passes, right? But this test fails, and it fails in a new way. The very first nibble, it actually reads out a whole byte. Okay, so I gotta fix that. Yeah, I think in Rust there are multiple passes of the compiler internally. And so sometimes it doesn't know about the other errors because it stops on one pass. It says, oh, there's an error, I can't continue. But if you fix that error, then it continues and it does another pass and it finds 14 more errors. Okay, let me think about why this would fail. So we made a new abstract syntax tree where we put 4 for the bound. So it's going to get to a elemental UI and it's going to see 4 for the bound. I think I know what's wrong, actually. I think the bound is not being applied correctly. So go to ingestion. So we're in a context, right? And actually, before we get to that context, it's using the bitstream's length for the boundary. That's the problem, right? We need to use the context's limit. Or context boundary, right? Wait a minute, it's optional? Why is it optional? If the composite has a bit stream, this is the offset of the bit after the last bit. Why is it optional? Okay. So the boundary is if we gave it a bit stream. So we're not obliged to give it a bit stream. We could give it nothing, but we happen to be giving it a bit stream. If we give it a bit stream, then it actually doesn't even take the bit stream. It's whatever limit we put in there. And so, okay, so let me go back to the test. Simple format, right? It's when it does this ingest. It forms the limit from, so it puts none, so it's going to be the length minus the offset, and the offset, so that'll be 0. So it'll basically be the bitstream's length. The bitstream's length will become the boundary. Then we go into context. And then we see UI. No, we don't. We're in a format called foo, right? We're executing statements. Let me think about this. Yep, we're executing statements out of foo with the whole length of the bitstream. So we execute statement. We get to the part. Okay, here's the interesting part, right? In build part, we actually get a limit out of that based off of the bound. What do we do with that limit? We attach a new bitstream subset to the data component. Data component, I think we're not using that, right? That origin, we're not using it. Okay, that's return from build part. So we build the part has an origin in it. And then we do ingest part. This thing has an origin in it, and we're not using it. That's the problem. Okay, so this boundary doesn't come from context boundary then. Did we already incorporate that boundary from build part in build part? No, this is just a suggestion. We didn't actually check it. We didn't check it at all. So it could be like anything. Okay, what is the correct thing to do here? I think we should not allow the construction of a limit that exceeds the current context boundary. We have the context here, so I think we should do a check here. Yeah, we should do a check here. So that limit can be no larger than the current boundary of the context. Okay, so let's do that here. So if limit is actually it's the current offset plus the limit, right? Context dot wait, we have the origin here. Yeah. If origin dot offset plus limit I need to make sure these are correct. Counting from the first bit, which makes up the data, and this is the offset in the bitstream of the first bit. If it's counting from the first bit, okay, there are these relative points, like there is no, this is bad to say because bitstream subset, there's no concept of a component. Shouldn't it just be relative to the bitstream? Then there really is no offset, is there? Oh, but this is used, it's where this is where it's used. It's associated with the data component. Okay, that's why. The data component, exactly. So this is the offset in the bitstream of the first bit. That's true. And then the limit is the bits left in the undermost. Okay, so it's counting from the first bit that makes up. It's counting from the first bit of the bit stream, right? Or is it counting from the offset? I think it's counting from the offset then. So if it's like the offset is 1,000 and limit is 8, that means that the thing starts at an offset 1,000 and its whole thing cannot be more than 8 bits long. Okay, then where was I done in ingestion? So origin is the composite. So if the origin's offset plus the limit is less than the bitstream's current limit. So we have to actually look at that, right? Where do I get that out? Is that origin dot bitstream dot borrow dot offset? The origin's offset plus the limit is the absolute limit. So yeah, if that's less than this origin dot limit, right? Plus limit, then it's an error. So we're gonna end up returning an ingestion error, and we have to actually say something here like the limit exceeds the bound. What happened here? That's usize. What's limit? Option. Why is that an option? Can I just say like, well, I guess I could put this, I could have okay none and okay some, I guess. Okay none is just none. And okay some. But then I'm gonna have to put some back in here. This is just to have like a verification check. I mean, I guess that's okay. I'm gonna copy from the C++ code. I know I did this somewhere in here. So that would have been in what? Not decomposer. De decompose, right? Oh, maybe it is decomposer. Yeah, okay, so it's oh, I don't remember exactly. It's in decompose and then execute statements and then statement part is here somewhere. Execute statement. Statement part. Blah blah blah. We get the bound. Yeah, here it is. This one, inner bound something surpasses outer bound. So it's always the offset plus the bound. Yeah, we're gonna print that. It looks like that my outer boundary is always it's relative to the start of the bitstream. So I changed that, right? Oh, and that's in the context, not the origin. Isn't that redundant though? No, it's not redundant because I can make a bounded region. I remember this now. There's a bounded region which sets an artificial boundary. Yeah, okay. So that means I need to fix this. This can't use origin offset plus origin limit. It's got to use the original the from the context the boundary. Unwrap. Yep, and then we're going to error paste. And then I guess gotta fill like this has got to be this thing. So let's just give this a name. Actually, let's give them both names. Let inner bound equals that. Let outer bound equal that. If inner bound is greater than outer bound, then inner bound surpasses outer bound. Okay, and then right. That gives us a limit which sets that, and that becomes the origin of what we put into the data component. So then there's an error here somewhere? Where's the error? I don't see it. Oh, right there. What's wrong with that? That's wrong with it. Okay, we have another error though. How did that happen? Oh, here. It should be, we've already checked the limit against the boundary. It should be the origin. What was this a little bit ago? I guess we copied it from down here, right? Exceeded boundary, bitstream.length, right? Bitstream is a bitstream. So origin dot so it would be like if the bitstream's current position plus. Oh wait, no, it's just that if the bitstream dot offset is equal to the limit. Yeah, that's it. I guess we didn't need that namespace or that lifetime. Use the word namespace for lifetime. I don't know why. Okay, minimal changes to get this test going again, right? Simple format. And just a byte. Pass. And just a nibble. It's still failing on that same line, and it's still reading a whole byte. Why is that? Okay, Oh, this is wrong. Yeah. Okay, it should be this way. Let n equal, or let bits, or length. I feel weird calling it len. How about bits equal limit minus offset? If bits is 0, then it's not that it's exceeded boundary, it's that it has no bits, right? I guess we'll just keep that for now. But yeah, if it's bits, and then this should just be bits. Okay, let's try that. Okay, we panicked right here. Panicked right there. How do we get there? Probably on bar. So we didn't actually store bar. Huh. Let's make sure. Okay, hold on. Let me make sure that actually it said it was that line, right? I lost the buffer it was in. Run the test again. Okay. Yeah, this unwrap. So it wasn't, it was that the value wasn't set. There was no overall value. Um, okay, let's I guess debug. BGR. Run again. Okay, so the reference is bar, and then another reference to bar, panicked. Wait, what? Why did it get in there twice? And I lost the terminal I was on. I hate this. It like closed this on me just because I started typing by accident. We referenced it twice? I guess we do, right? No, we only referenced it once. Wait, what? How did we reference bar twice? Okay, I don't get that. We evaluated the reference expression twice. Let's do a breakpoint. And I hardly ever do this. We can do debug now, right? Debug. Okay, and then I'm going to look at the call stack for this thread. Okay, we got to the return statement, basically. Variable part format UI, and it has a value, right? Some. Huh. Right, it has the value 1. Oh, so we did get the nibble. It's the nibble that has 1 in it. Okay, so then this succeeds, right? So let's just hit go, and now this is the problematic reference. Wait, why are we in the return statement again? Oh, because we're calling it a second time. That's why. Okay. So the second call is panicking. So let me put a breakpoint there. Stop and start again. So yeah, I don't need to see that one. Go to here. So what does bits look like right now? Local bits. There are 3 references to it. Does that make sense? I guess so, because yeah. Raw pointer, pointer, value, value. We can't look at it. Well, that's the problem with Rust stuff, right? It's inside of a ref cell and all that stuff, and it just doesn't know how to interpret it. It's like, I don't know. I don't know what that is. You can look at it in hex if you want. Let's step in. Actually, then I can look at origin. Okay, it's at 4 bits and there are 4 more bits. That makes sense, right? Because we gave it a byte. So it's 4 bits in, there's 4 bits left. Okay. Over, ingest, out, in. Okay, what's the boundary? Sum 4. So, oh, that's not right. The boundary should be 8, right? Is that what's going on? Boundary should be the current bit streams. It should be the origin offset plus the origin limit. I think that's the problem. Yeah. Let's see if that's what's going on. So it forms the context, ingests in context, goes into UI. Actually, no, format's foo, so it's going to skip all that. It's going to go into this, find the format, execute the statement, execute statement. It's a part, so execute part statement. The name is bar. We're going to build that part. We got an error. What? We got an error. I guess we didn't get an error? No. Right. Okay, we got an error. Why do we get an error from building a part? Okay. Let's put a breakpoint there. Run it again. So go. Okay, I'm going to step into this. Bound is some. Oh, that's an expression, right? Yeah, we have to parse it. So some origin. Okay, we got a limit of 4. Inner bound is 8. Wait, why is the inner bound 8? Oh, it's the offset plus the limit. And the offset must be 4. Yep, so we're hitting this error. Oh, and we have no logger. That's dumb. Yeah, our tests aren't setting up a simple logger. That's why we're not seeing our error messages, because we're not bothering to log to actually make a logger. Okay, yes, so this boundary calculation's wrong. That's what's wrong. Okay, so let's go fix that. Boundary final references is set around here somewhere. Here. So it should be origin.offset plus origin.limit. Okay. Run test. Oh, is it still failing? Okay, let's get rid of the debug part. Let's get simple logger going. Simple logger, right? Simple logger. It's at version 4.2. So close that and go here and ingestion, dev dependency is simple logger 4.2. Okay, and then how do we use it again? Oh, okay, so we just do it anywhere. Okay, so why don't I just do it at the test level in ingest? Well, actually, ingest is called multiple times, right? Why don't I just put it into the test for now? Qualify. All right, then we'll run it and we'll see hopefully see our error message. Our window is really small. Exceeded boundary. Really? I didn't expect to see that. So that's in the elemental UI, right? Right here, right? Debug. Go. Yep, it's 0. So what's origin limit? 5? Why is it 5? What? Hold on, let's see what it is every round through. So stop and go again. How come that button doesn't work now? There. Don't know why the button wasn't working. Offset limit 4, that makes sense. And then go. And then we get to the second one, right? Offset 4, limit 4. Wait. Why is the limit for? Oh wait. Yeah. It should be it's counting from the first bit, which makes up the data for the composite. Yeah. Okay. Where's the debugging? Which one of these is the debugging one? How come it doesn't show up here? Wait, does it just like disappear when we're not debugging? Okay, is it just gone when we're... No, it's there. Okay, I don't know what I was... Just get rid of these. Oh, it does disappear. Wow, okay. How do we get it back if we wanted it? Oh, testing? No, not testing. It's run and debug, right? This one. Okay, I want to keep that up. Is it because, yeah, we have too many tabs, that's why? Shoot, what do I not use? You don't use source control. Don't use CMake. Yeah, okay, that we'll just keep it like that. Okay. I have to get these straight. Like, what does this mean? Counting from the burst mixup. So that's too vague. I need to be very specific about this. It's when these get put into a data component, right? So, how do we get to elemental UI? That's in ingestion. Binary references. Okay, it's when we're ingesting in a certain context and we're using that context. So by that point, the offset and limit will be set correctly. So yeah, then it's just limit. There's no offset. There's no offset. Yeah, so this we don't need bits. It's just, well, I guess we could say that. Bits. Actually, it should just be origin limit here. Bits is 64. Here we should say let bits equal origin limit. And then bytes. Well, this should say bits. And bits again here. Okay. Let me make sure I did this correctly. Yeah, this should be origin. What are we using for length? Yeah, that doesn't make sense. That's when we used to have the each component had its own subset bit stream. Yeah, okay, this makes more sense and we don't need this anymore. Need to fix all these warnings. How confident are we that this will pass? Pretty confident, right? Yep, it passes now. Woohoo! You know what I'm gonna do? I'm gonna put this in a comment with a to do. Get this to be set up for all tests in one place. So maybe we just have all the tests call something, or maybe I look up a crate that does like common setup or something. So these should all run now, right? Yeah. So I should be able to run all the tests in simple format. Like this. There. All tests pass. Run the bit tests. Run the decimal tests. Run the references tests. They're all passing. Woohoo! Okay. Passing all our tests. In fact, let's run all of our tests everywhere. I'm happy. Got it to pass all our tests. Good. I think it's time for me to go get some sleep and then work on this again in the morning from a good spot this time. Actually, should I stay up a little bit longer and fix my warnings? I got 31 of them. Well, we already have a to-do. What if I just ignore that for now? Yeah, we're going through and we're fixing warnings really quick. Yeah, everywhere where we have a to-do, I think I'll just do a dot dot for now. Dot dot. Yeah, you just do a dot dot. In fact, why doesn't that just collapse it to one line? I don't know why. Dot dot. And a dot dot. This doesn't need to be mutable because we own it now. Or not that it's that we own it, it's that we're pulling things out of it. Component. Well, this is referencing it. This is pulling out the component from the argument separate. Yeah, same thing here, right? We're just pulling things out of it. And we don't use the arguments yet, but we will. We have a to-do for that. Okay, dot dots all around here. Everything that has to do, I don't need to like remember things. I'll just have it fill in the, like when I want to do ignore, what I'll do is I'll remove the dot dot and then do fill structure fields and then back to where I was. So if I can get back to where I was with the editor's help, I don't need to actually save the names there. I might as well just get rid of the names for now. Leverage the to-do. Okay. 2 warnings. Let part equals entry insert part. Why did we do that? Oh, and can I chain this again? Can I do that? I can. Okay, good. So build, ingest, or it's an error placeholder. Actually, then this can be reduced to a lot less, right? Because can't we just do insert on this? Because insert tells you if it had a key present. Oh, we don't want it to update it though. That's why. Yes, so but I don't need the reference that we get back out. Okay, good. Build part. Redundant closure. Just use U-size try from. Do it. Hey, it just works. That's cool. Hey, no warnings, no errors. Cargo, Clippy, and then tests. We got no warnings, no errors. And all of our tests pass, right? All passing. Every single test. Okay, great. Then I think I want to like look for these. It was this, can we get rid of some of these namespaces? And I mean, I keep saying namespace. It's lifetime. Can I get rid of these lifetimes? Okay, we need a lifetime bitstream handle. Why? Okay, can I get rid of this lifetime? I can. Great. Can I get rid of this one? No, I can't get rid of that one. Why? Oh, right. Now we're going to see, can we get rid of this? Yes, we got rid of it. Well, actually, we got 3 errors now, but maybe we can fix the errors one at a time. Okay, cool. 2 errors left. You finished a 7-paragraph essay? Good job, son of Raimu. Spawn of Raimu has finished a 7-paragraph essay. Yeah, we don't have to say that. 1 error left. Trait doesn't need... Okay, yeah, just get rid of that, right? Now can I get rid of that? Awesome. No, I can't. There are 4 errors now. Hold on. One, if I get rid of that, there are now 4 errors. Errors elsewhere. Oh, because the parameter is never used. Let's solve that. Yeah, so this is never used, so we can get rid of it. Wait, what? Parameter bitstream is never confusing it, referring to a field. Okay. But yeah, doesn't that propagate everywhere? Missing a lifetime sys error. Well, we don't need one. Okay. This is all great. So can data component get rid of... Yeah, it's an error to have it anyway. So we're getting rid of it. Okay, we have errors though. We got errors, we got errors. Hopefully getting rid of this everywhere gets rid of the errors, actually. Really hoping it does. I think this should work because we now buttoned up the bitstream into a ref cell, right? So yeah, we shouldn't need any of these things. All this should go. And 3 errors left. Context doesn't have that. This doesn't have that. So this is redundant. 1 error left. That can go. All of these can go. That can go, right? Yep. Didn't need it. Go back in time to past Raimu and tell him he doesn't need any of that any of that lifetime garbage. So the reason why I was able to get rid of all of those lifetimes is that Bitstream no longer constructs clones of itself. If it did, then because buffered Bitstream does have a lifetime, we wouldn't be able to do it. Actually, let me see if I can prove that. So if I put it back to where it was, yeah, that subset thing. If we put that back in here, and we just said, let's say we try to implement this for buffered bitstream. I don't think it's possible to implement this for buffered bitstream. Let's see if we can. Set offset after that, right? Okay, so far so good. And then, so yeah, it would be box new self. I think it was just impossible to specify this correctly because we're ending up taking self dot input and then taking like some offset from that to like I think it was just like offset divided by 8 up to offset plus length divided by 8. Like that. And then the offset, yeah. Yeah, so we ended up with this thing lifetime not, and I couldn't figure out how to fix that without starting to annotate things with lifetimes, and that just corrupted everything. Right? Lifetime may not live long enough. Returning it requires that input must outlive static because, and that's because the box implies that it's static, right? Lifetime input defined there. Returning this value requires that the input lifetime must outlive static. And that's because we're putting it in a box. So like, yeah, I was trying to like fix that by saying like, well, but we can limit this to input, right? But then this doesn't match, right? It's not compatible anymore because it expects it to be for the static. So then I'm like, okay, well, then that infected this thing with a certain bit stream lifetime, right? In order to put it here. But that led to this thing. Yeah. Just like the errors just led one to another, right? It's like, well, okay, well now this thing has to have a lifetime. Actually, can I just put that in there? No, it has to be named, right? Oh, I can make, ooh, maybe I can fix it this way. No, there are errors on the other places. Yeah, I think I ran into this problem too. Um, clear. Yeah, it was this self, right? So it's supposed to return data with lifetime input, but it returns a lifetime with lifetime of 1 because we're using the self reference to get to input. And yeah. This I don't know how to do. I don't know how to implement this without because okay, so I tried to solve that by putting input here, and that caused more problems, right? Now it doesn't match, so then we have to go back and put it here. Bitstream. But then that leads to more problems. So it gets everywhere, right? That it escapes now because of that. Borrow data escapes outside a function. Requirement occurs because of the type ref cell. That for any lifetime, for some lifetime that it, okay, it's because it's static there, right? Yeah, I think it's because ultimately, was it this? One of these? Yeah. Um, actually, can I just say that? Maybe that fixes it? No, it doesn't. Why not, by the way? It's not declared. Yeah, so anyway, it's a huge mess. So I say let's not do it that way. So we get rid of this and we're all back to normal soon. Got to just get rid of some of the stuff I added just now. Cool. So do I have any lifetime bit streams hanging around? No. How about context? No. Okay, good. Terminal. Clippy. Tests. Cargo. Run tests. Everything's good. I'm gonna back this up. Send it out of the virtual machine. Cool. So just to review, like I should have everything implemented now in the elementals, and I'm gonna move up to the higher order stuff. So the elemental should have everything done. Let's make sure. This should not have any unwraps here. Okay, we do have one to do here. Should we warn an error if the limit is greater than 1? Like basically, we gave the bit more than 1 bit. I think the answer is no, because the limit, if we didn't bound it, if we didn't put a bound on the bit, it's going to default to be however many bits are left for the rest of the what's in the context right now, right? So that's fine if the limit's greater than 1. So yeah, I can reason that one away. So make sure that there are no unwraps here. So the errors are being logged, but we're not forming a new ingestion error that maybe we should, right? That's something to consider, that right now ingestion error is just kind of a placeholder, and at the top level we'll just see an error is set to true. We won't really know why there was what the error was. Hello, Steely. Okay, elemental UI. I have a to-do to support that. How would we support 64-bit unsigned integer? I guess we would have an alternate data value type called unsigned integer. And we're just, yeah, I wonder how hard that would be. I've been live for 5 hours, yep. And I'll be sleeping for about 6 hours and then going again for maybe another 2 hours before work. If I keep going, then I won't get enough sleep. I'll have to skip the next stream in the morning. I don't want to do that. Maybe we leave this for tomorrow. And yeah, the answer is no for this. You just woke up. You must be on the other side of the world. Yeah, I'm just making sure I don't have any unwraps, that these are done. The only thing that's not done then is supporting a full 64-bit unsigned integer. And that's because we use I64, so it's really 63 bits. Yeah, here it's 11:51 p.m. You must be in Europe somewhere. So yeah, during my normal stream time, it would be your evening. Yeah, Eastern EU. Okay. I think I'm done with these things. So how many to-dos do we have in the code? 20. So we're not coercing decimals to unsigned integers. Binary operations not supported. Functions aren't supported. Maps, nil is not supported. Oh, that should be easy. I could do that one right now. That's just, we need to make a data value type called nil. Set not supported, unary operators not supported, vectors not supported, ignores, conditionals, for loops, while loops, bounds, locals, assignment, accumulate, increment, decrement, break, and error. Okay, so that's 20 to-dos, and then how many unwraps do we have? Okay, we have got 13 of them. So yeah, we have an unwrap for that the references have to match, and then we have an unwrap for the value has to be there. Right. Okay, and then format has to exist, and arguments have to evaluate correctly. There has to be a boundary. Well, there always will be. That I need to check. Yeah, we need to handle that specially. Actually, no. We should always have a boundary if we have a what is it? If we have an origin. If we have an origin, we should have a boundary. So I need to look at that again. Like why does that have to be an option? Why can't that not? It says if it has a bit stream. So is that the problem? Is that it's stored separately? It's stored in here, right? Right there. So and there's no real way to combine it with that, is there? So it's if this is something, then this is something. How many different places do we use that? Let's rebuild. Actually, we can actually see that here. We do a map. So it'll be something if the origin is something. It'll be none if the origin is none. That's why one follows the other. Yeah, that just gets inherited. And there's where we check. So maybe that unwrap stays because so then I think I would kind of call it an expect. And we should never get here. If we ever get here, it's a design error. And the design error would be part has origin, but no part has origin without. How do we write this? It's not that the part has an origin, right? It's that the composite has an origin. Composite has origin without boundary. Yeah. So this should never happen. If it does, it's a compile time or it's a design time thing, and that's sort of saying like what it's kind of like an assert, basically. Okay, back to searching for unwraps. 12 unwraps, right? You'll have to fix that. Fix that. Oh, this is a test, right? So we don't have the tests don't count. Tests we allowed to panic. Okay, so we don't have that many unwraps. They're all in tests, right? What is this? From location. Oh yeah. That's well, hold on. This we should expect on. These are assembled from strings, right? And those strings are actually, I don't know where this is. What if I comment this out and see what breaks? What breaks now? A bunch of things. Oh yeah, it's our the locations we put in the test cases. Okay, so then undo that. We do want to expect here. So it should be expect bad line number. bad column number. So if we ever see that in a panic, then we'll know that we bungled the test. Okay, back to unwraps. 10 left. Scare unwrap. Hold on. What is this again? This character's next. Look ahead is character's next. If it's some, oh yeah, it's impossible for this not to be, because we're looking ahead. We can never go from nothing to something. So this should just be expect. How did we get something from nothing? And that's just because I'm walking two iterators in a line, right? It would be if we did this wrong, right? Look at his cares next. Wait, when do we assign this care? Oh, right here, yeah. So look ahead is always one ahead of this care. So this care can never be nothing. How do we get something from nothing exactly? Parse. Yeah, we should never hit this because the names we got from the keys, right? Actually, that's because I wanted to sort the keys, right? So this be expect. We lost the value. We lost the key went missing since we sorted the keys. Okay, because that should never happen, right? That's build time script, so we want it to panic if it fails. This we want to unwrap by, right, that means the colon is missing. So expect missing colon in line column. Okay. So we actually don't have very many unwraps. This is good. So we have some, like not counting tests, not counting test, not counting the build time. So we have 1, 2, 3. Just make sure they're valid. Yeah, 4. So we have 4 unwraps we have to fix, and then we had 20 to-dos, and some of them are big. Some of them are tiny. Some of them are big. That's not bad. And I think this is the first thing I'm going to do tomorrow morning. We're going to see about, can we support full 64-bit integers? Because I don't think it'll be too bad. The way this should work is we should just be able to add unsigned integer value type, and then we'll have to add another, we might have to add more trifroms, right? So in some contexts, we might need an I64, and others we need a U64. And so we'll have to add different trifroms for data value. All right, so a trifrom unsigned integer would have one just like integer has. And we might have to do trifrom data value for I64 and U64 later. Shouldn't be too hard. But yeah, I think that's it for me. I gotta go get some sleep. It's the midnight bell has tolled. There's probably no one streaming right now, right? His mercenary mage. I haven't rated him in forever. I'll leave you with someone who's doing game development. I will be back tomorrow morning, hopefully. Get a little bit of sleep, and then I will be back. So thanks for watching. I'm glad we got all the errors sorted out, and we'll be making some new progress with new tests tomorrow. Good night, Steely, or have a good day, and I will see you later. Bye.